everyone. Am I audible?
Yes, ma'am.
Yeah. Thank you, sir. Good morning, everyone. Welcome to the day 8 of the Joint Faculty Development Program on Python Programming for Engineering Applications, jointly organized by Electronics and ICT Academies at IIT Guwahati, IIT Jabalpur, IIT Roorkee, and IIT Patna and MNIT Jaipur. So I welcome you all to the day 8 of the program. The expert for today's session is Dr. Mukesh Kumar. So before handing over the platform to Sir, I would like to give a brief introduction of Sir. Dr. Mukesh Kumar Sir is an assistant professor in the Department of Computer Science and Engineering at the National Institute of Technology, Patna. He completed his BTech in Computer Science and Engineering from Cochin University of Science and Technology in 2011. He then pursued his MTech and PhD in Computer Science and Engineering from NIT Rourkela, completing them in 2013 and 2017 respectively. Following his PhD, Dr. Kumar gained valuable industry experience as a data scientist at ABB GISPL in Bangalore. Dr. Mukesh Kumar has made significant contributions to the field of computer science and engineering through his extensive research and publications. He has supervised many students at UG, PG, and PhD level and authored over 50 peer-reviewed journal papers, peer-reviewed research papers focusing on areas such as big data, machine learning, deep learning, and recommender systems. His work has been published in prestigious journals and presented at various international conferences. With this brief introduction, I would like to hand over the platform to Dr. Mukesh Kumar, sir. Over to you, sir.
Thank you, ma'am. Thank you for nice introduction. Good morning to all of you. Today I will take the lecture of exploratory data analysis using Python, in which we will see how Python can be used or different packages can be used to analyze different data sets. So I am sharing my slides. So we will start the session now. Okay. So I think my slide is visible to all of you. Please let me know.
So your screen is visible, but slides are not visible.
Is it okay now?
No, sir, your slides are not visible.
Let me start the session with browser. My actually app is not allowing me to play. I'm sharing but not visible to all of you. So is it visible to all of you?
Yes, sir. Now your slides are visible.
Okay, thank you, ma'am. So we start from here. Exploratory data
Yes, sir,
analysis.
visible.
Okay, thank you. So before going to the ADA, we start with the data science life cycle. What are the things we have to consider first? So actually, why is data science important? Because we have much amount of data, explosion of data. The online world see the massive surge in data like never before. The internet, social media, and smart gadgets create huge amount of information that also we can categorize the understanding this vast data set is big task. And data science tackles it with analysis and prediction. So big data is not just a tech problem; it is crucial strategy. Organizations that use data efficiently get a complete advantage, and they can uncover hidden patterns, identify trends, make data-driven decisions that propel them ahead in the market. So here we will see how big data technology can be used to do the same EDA using Spark. So in these sessions, we will study about the NumPy pandas, and we will use some exploratory data analysis using panda, and then we will use Spark to do the same task. So first task for any data analytics is successful data science project lies in a clear and precise definition of the problem at hand. So in this stage, it involves collaboration between data and the stakeholders to identify and articulate the business objectives. And the key is to translate high-level goals into specific, measurables, and achievable tasks. So without a well-defined problem, subsequent discussion with stakeholders, and it should have clear for the goal formulation. So what from means from starting point to end point, what is our end point for that? So once the problem is identified, the next step is to formulate the clear and measurable goals so that and to achieve the goals we do these things. So after identifying the problem, we our aim is to collect the related data sets. So to analyze the things. So with the problem clearly defined, with the focus shifts to gathering relevant data. Data collection involves information from various repositories, APIs, or external database datasets. And the choice of data source is critical, and it directly influences the quality and applicability of the subsequent analysis. So, first of all, the comprehensive data sourcing. The data scientist must cast a wide net to ensure they capture all relevant informations. This might involve collaborating with different departments within the organizations, integrating data from the third-party sources, or utilizing publicly available datasets. The goal is to create the comprehensive dataset that provides a holistic view of the problem and the quality assurance. So ensuring the quality of the collected data is paramount. Data may be prone to errors, inconsistencies, or missing values. Rigorous quality assurance process, including data validation and verification, are implemented to guarantee the reliability of the dataset. The next step is data cleaning and pre-processing. So raw data is seldom ready for analysis. So data cleaning and pre-processing involves transforming the raw data into usable formats. And this phase addresses issues such as missing values, outliers removals. If dataset having any outliers, then identify them, and if they are unuseful, then remove them. That and inconsistencies, ensuring that the data is suitable for further analysis. So how imputation and handling missing values. So missing data significantly impact the accuracy of models. Imputation techniques such as mean imputation, median imputation, or predictive modeling based imputation are applied to estimate and fill the missing values. Next step in pre-processing is standardization and normalizations. So data often comes in different units or scale. So standardization and normalization technique are employed to bring all variables to a common scales, preventing any particular features from dominating the analysis due to its magnitude. After doing the data cleaning and pre-processing, exploratory data analysis step has come. So this phase is where data scientists deep dive into the dataset, unraveling its patterns, trends, characteristics, and this phase employs statistical analysis and visualization technique to gain insight that will inform subsequent modeling and decision. Okay, and then we do the statistical analysis, so descriptive statistics or inferential statistics, and other statistical measures are applied to understand the central tendency, dispersions, correlation within the data. And this qualitative analysis lays the groundwork for more advanced modeling techniques. Then we do apply the visualization technique for insight generation. So data visualization is a powerful tool for communicating complex pattern in a digestible form. So graph, charts, dashboards help in identifying trends, outliers, and potential relationships within the data. So visualization not only adds the data scientist but also facilitates communication within non-technical stakeholders. So these two steps are very important in any type of EDA. So after doing the EDA, our aim is next step is model building. So data scientists armed with deep insights construct models based on machine learning and deep learning. And these models unveil pattern, predict, and classify data. So selecting suitable data algorithms hinges on the problem and data tracks. So in this step, our main aim is to select best algorithm. So which type of algorithm we can select so that problem will be solved. And then data splitting between training and testing. Based on that data set, we train our models and then do the testing, do the validation and testing, and then we assess the performance of that model. Then a model evaluation. Then after measuring the performance of the models, means the effectiveness of the model is assessed using various matrices that measure its accuracy, precision, recall, and other performances. So this step involves through testing to ensure that the model meet the predefined goals and provides valuable insights. So here classification metrics or based performance metric like accuracy, precision, recall, F1 measure, and for regression problem we can use like mean absolute error, R squared. So the choice of metrics depends on the project's specific objectives. And then we refine our models based on the problem given. Means after some amount of time we again retrain the model and do the it. So it is a iterative process, and if the model sorts falls short of expectations, then data scientists go back to previous stage, adjust parameters, or even reconsider the algorithm choice. And this iterative refinement is crucial for achieving optimal model performance. And then deployment and maintenance. So after doing training and all these things, we deploy the model and timely we maintain the model. Okay. So our main focus for this lecture is exploratory data analysis. That is fourth step. We will start from here. So what are the things we have to consider? So what are the first here we will know means data objects, attribute types, basic statistical descriptions of data, data visualization, and then measuring data similarity and dissimilarity, and then we summarize. So what are the types of data sets? It may be in the form of record, like relational records, data metrics, that may be numerical or cross table, document data, like text or based on time frequency vector, transactional data. Data may be of graph and network type also, like www, that is data comes from social media and information networks or molecular structures. Data may be of type ordered, like video data, that is ordered based on the time stamps, that is sequence of images. Temporal data, that is time series data. Sequential, that is based on transaction sequences. And genetic sequence. Next may be of spatial, image, and multimedia type. So, like maps and image data and video data. We have. So, important characteristics of a structured data may be like curse of dimensionality problem, only presence counts, resolutions, distribution. So data sets are made up of data objects, and data objects represents an entity. Like in, for example, a sales database, customers, store items, sales are data objects. In medical database, patients and treatments are data objects, and in university database, students, professors, courses are data objects. It is also called samples, examples, instances, data point, objects, or tuples. And these data objects are described by attributes, that is called features also. So attributes may be called as dimensions, features, or variables. It is a data field representing characteristics or feature of a data objects. Like in customer data set, customer ID, name, and address are the features of that data sets. It may be of type nominal, binary, numerical. So attribute types depend are of different types like nominal. So it may be of category type, states or name of things like hair color, like black, blonde, brown, gray, red or white. That is nominal type. It may be also of ordinal type, that may be of sub order like good, average, best kind of thing. It may be of binary type like nominal attributes with only two states, 0 and 1, like in gender, male or female may be of binary type. Symmetric binary, like both outcomes equally important, that is gender. Asymmetric binary, that is outcome not equally important, like in medical test, positive or negative. So conventionally assign one to important outcome. It may be of ordinal type, so value have a meaningful order or ranking, but magnitude between successive value is not none, like a small, medium, large kind of thing. So numeric attributes may be of qualitative type and quantitative. Qualitative type, it is of integer or real value. It may be of interval, like measured on a scale of equal size units. It value the value having some order, like temperature. It may be of a zero type, means ratio, inherent 0 points. We can speak of value of being an order of magnitude larger than the unit of measurement. So data may be of discrete or continuous attribute. So discrete attribute has only a finite or countably infinite set of values, like zip codes, professions, or the set of words in a collection of documents. Sometimes representing an integer variables. Continuous attributes maybe has real number as attribute values like temperature, height, or weight. And practically real values can only be measured and represented using a finite number of digits. So continuous attributes are typically represented. Okay, as floating point numbers. So before going to these things, so data may be of means some we have some populations, and from some populations we take some samples. Okay, and on that samples we do the descriptive statistics, and after doing the analysis, we take inferences from there, and that can be applied on the complete population or whole population. So from the population, we can see that big circle is a population and a smaller circle is a sample. Okay, so based on some probability, suppose based on some selection criteria, we have selected some samples from the populations, and on that sample we do the descriptive statistics, and then after doing this, we consider the inferential statistics on the whole population. So why it is very essential to examine all variables? So to listen to the data, to catch mistakes, to see patterns in the data, to find violations of statistical assumptions, to generate a hypothesis. And so these things we have to consider in this phase. So these are the type of data like categorical, quantitative. But categorical may be of binary, nominal, and ordinal data already we have discussed, and qualitative may be discrete and continuous time. Dimensions of dataset, it may be of univariate type, bivariate type, and multivariate type. So univariate means measurement made on one variable per subject. Bivariate means measurement made on two variables per subject, and multivariate means measurement made on many variables per subject. So how to summarize the data set? So numerical summaries of data like central tendency measures, they are computed to give a center around which the measurements in the data are distributed. So central tendency, that is. Next one is variation or variability of measures. They describe data spread. So how far away the measurements are from the center. Relative standing measures, they describe the relative position of specific measurements or in the data sets. So next term is mean. So how to calculate mean? We all know. So to calculate the average x bar of a set of observations, add their values and define the number of observations. So suppose the data set having x1, x2, x3, and so add all these value and divide the total number of samples, that is n. That will provide mean. Other type of means are weighted means. So we provide some weight to each data points and multiply that weight with that data points and then do all the summation divided by total number of weights. Okay, and trimmed means we trim that means we suppose that is alpha. Geometric means we have to multiply all the data points. Okay, and then take the roots. Take the nth root. Means suppose we have n number of points, then take nth root. Multiply all n points, and nth root of the complete multiplied. This will provide you the geometric mean. Harmonic mean, it will give me n divided by sum of 1 by xi. Means we have to take the reciprocal of each data points, then sum, and total number of sample divided by these sums. That is harmonic mean. So based on the problem, we can calculate different types of means. Next term is median. So it is the exact middle value of any data set. So if there are an odd number of observations, so we can find the mid value, and if there is an even number of observation, then find the middle two values and average them. Okay, so in these examples you can say we have age of participants like 17 years, 19 years, 21, 22, 23, 23, 23, and 38. So to compute the median, what we will take? First of all, we sort the value and then take the mid one. So if total samples are odd, then the mid one will be the median, and if total number of samples are even, then we take the two elements, that two mid elements, and take the average of that. So kindly mute. Hello. I think mic is on for participants.
அதெல்லாம் எரர் வர்றது.
Please be quiet. Wait.
Facilitator, please mute all participants. No, you cannot mute it. Only facilitator or participant only. B. Venkateswari, please mute yourself.
சொல்லிட்டல்ல ஒரு மனுஷி எப்படி மேனிபுலேட் பண்றாங்க.
Coordinator,
Hello.
Also can mute the
can we mute
participant.
it?
Host
Hello.
also can mute the participant.
Coordinator, can you please
Hello.
mute Venkateswari?
Hello.
Yes.
Yes, sir, you are.
Okay. It's okay. Yes, ma'am. It's okay now. Okay. So we have discussing about mean and median. So how we can compute means and different type of means like thematic mean, geometric mean, harmonic mean, weighted mean, and median. These are the basic things we can compute from the data. And so which location measure is based? So mean is based for symmetric distributions without outliers. So if data having symmetric distribution, if we are mapping in Gaussian curve or any type normal distribution curve or uniform things. So a data set having no mean is the best symmetric, mean is the best, and median is useful for skewed distribution or data with outliers. So you can see in these examples, mean is 3 and median is also 3. But in this second one, we have outliers like 10. So mean is 4 and median is 3. So that is means all the data points 1, 2, 3, 4 are at the in particular side and others are there. So if we consider median, then you will get the most means useful information from the data. Next parameter is variance. So variance is nothing but average of square deviations of values from the mean, and it can be computed like calculate the difference between each data points with their mean and square them and then sum all these things and divided by degree of freedom n minus 1. So why a square deviation is required? So adding deviations will yield a sum of 0 and we have negative value and positive values. So absolute value don't have nice mathematical properties also. So a square eliminates the negatives and it results increasing contribution to the variance as you go further from the mean. Okay, so how data are dispersed from the central point? We can measure with the square deviation. So variance is somewhat arbitrary, and if we could standardize that value and we talk about the any variances that is with deviation in equivalent term, so it is a square root of variance. So standard deviation is nothing but a square root of that variance, and this can be computed like this. We calculate the variance and then take the square root. So theoretical result like means how our data is distributed. So at certain percentage value must fall within k standard deviations from the mean. So that is can be computed like mu plus minus sigma. Okay, so 65% of data are captured within 1 plus mu plus 1 sigma, and 75% is mu plus 2 sigma, 89% is mu plus 3 sigma, plus minus 3 sigma data are captured. So in this type of theoretical results can be analyzed. So 68, 95. So if their histogram means if we draw the histogram plot of our data set and that is of bell shaped, so roughly 68% of the observations in the list lie within the one standard deviation of the average means mu plus minus 1 sigma. 95% of the observation lie between two standard deviations. In this way, we can make the data. Next term is quartiles and IQR. So in this one, how we find the quartiles? We sort the data sets and divide into four parts. Like here, boundary is Q1, Q2, Q3. So first 25% data is first quartile. Then next 25 is Q2, Q3 in a similar way. Okay, so the first part at Q1 is the value for which 20% of the observations are smaller and 75% are larger. Q2 is the same as the median. It is also median, that is mid value of the data set. So 50% are smaller and 50% are larger. And Q3 is 75% is smaller and 25% are larger. That is third quartile. IQR is difference between Q3 and Q1, that is IQR, interquartile range. So percentiles, how to compute? So in general, the nth percent is the such that n% of the observations falls at or below a field. Okay, so in a similar way, we can plot the graphical summarize. Means we do the summarization of data using graph like box plot, bar plot. So bar plot is used to for category values to show frequency or proportions in the each category, and it translates the data from frequency tables into a pictorial representation. Histogram is used to visualize distributions, shape, center, range variations of continuous variables. It is based on the bin size, means how many to plot the one histograms, how many pins or how are selected, like 5, 10, 15. Kind of. So effect of bin size on histogram. Suppose we have taken the normal distribution of hundreds of samples and 500 with standard means mean and standard deviation 1 1 and 0 and 1. So after selecting this one, we can see how they have been drawn. In a similar way, we can plot box plot. So in that we have this is the minimum point, this is the Q1, median, Q3, and maximum, and this is the IQR. So if any value coming to the this whisker outside the whiskers or below the whiskers, then we can say that that is outliers or inliers for that particular plot. For multivariate data, that is clustering, organize units into clusters based on descriptive, not inferentials. So clustering is based on descriptions. It's having many approaches. So next thing is PCA. So it is the reduce the n-dimensional data set into much smaller numbers. Find a new a smaller set of variables that retains most of the information into the total samples. So first, principal components. If we talk about the principal components, so principal component may be the axis along which we are taking the components of all the data points. So these are the basic statistical description of data like mean, median, minimum value, quantiles, outliers, variance, and numerical dimension correspond to sorted intervals, that is data dispersions analyzed with multiple granularity of precisions. Box plots or quantile analysis on sorted intervals we can do. Dispersion analysis on computed measures, folding measures into numerical dimensions, and box plot. A quantile analysis on the transformed cube may be done. So in this way, we can measure like mean, median, mode, and you can see how based on these parameters how we can decide whether data is symmetric or skewed. So if mean, median, and mode of the value are same, then we can say that these are symmetric. The data set is symmetric in nature. So you can see if mean is greater than median, and then we can positively skewed, and mean is less than median or mode, then it is negatively skewed. In this way you can make the assumptions about the data sets. So which type of data we have, like symmetric, positively skewed, and negatively skewed. So measuring the dispersion of data like quartiles, outliers, and the quartile is the Q1 means 25th percentile. Then we calculate the interquartile range IQ or Q3 minus Q1. Then minimum, Q1, median, Q3, and max. We have five number summary. Box plot ends of the box are the quartiles. Median is marked. Add whiskers and plot outliers individually. So outliers usually a value higher or lower than 1.5 IQR means that is Q1 minus 1 plus 5 plus minus IQR. That is. So in this way, we can draw data dispersion in 3D box plots. And these are the properties of normal distribution curve. So mu plus sigma plus minus sigma contains 68% of measurements. Mu plus minus 2 sigma contains 90% of it, and mu plus minus 3 sigma contains 99.7% of it. So box plot, it is a graphic display of five number summary. Histogram x-axis contains the values and y represents the frequencies, and it depends on the bin size. So on that particular bin, the data, what is the frequency of that particular data points. Quantile plot is its value xi is paired with some features fi, indicating that approximately 100% fi of data is less than xi. Okay. Next plot is quantile plot, that is also called QQ plot. It is the graph that quantiles of one univariant distributions against the corresponding quantiles of another. So we take the different variables and we calculate the quantiles of each variables and we draw the graph between the quantiles. A scatter plot where each pair of values is a pair of coordinates and plotted as the points in the plane. So histogram analysis. It is a graph display of tabulated data frequencies as shown in the bar. So as we discussed, we select the bin size, and based on bin size, we select the frequency of any data points in that particular bin. Okay. It shows the what proportion of cases fall into each of the several categories. It differs from a bar chart in that it is the area of the bar that denotes the value, not the height as as in the bar charts. Okay, so means it's taking the actual value. It's taking only the frequency of that value. So it is a crucial distinction when the categories are not of the uniform width. The category are usually specified as non-overlapping intervals of some variables. The categories must be adjacent. So quantile plot it displays all the data, allowing the user to access the and overall behavior, un- unusual occurrences. Plot quantile informations. So in this graph, you can see for a data xi, data is sorted in increasing order. Fi indicates that approximately 100 fi% of the data are below or equal to the value of xi. Small square is quantile you can say. So we have f value and unit price. So corresponding to each f values, what are the unit price, quantiles of unit price we have to draw. So a scatter point where each pair of values is treated as a pair of coordinates and plotted as points in the plane. So you can see from the scatter plot, we can infer that in the first graph, this is the positively correlated. All data points are positively correlated, and in this one, negatively correlated. So as data is going, the response we can measure as also decreasing. In this one, it is a mix. Okay, the first half is positively and second half is negatively correlated. You can measure. Means from the scatter plot we can assume means make the assumptions like that. These are uncorrelated data points. So data visualization provides insight of information by mapping data into graphical primitives. It provides qualitative overview of large data sets. It searches for patterns, trends, structures, irregularities, relationships among data. It helps to find interesting regions and parameters for further quantitative analysis. It provides a visual proof of computer representations derived. So data visualization may be of different types like pixel oriented, geometric icon based, hierarchical visualization based, and visualizing complex data and relations. So this is a pixel oriented based visualization. So for a data set of m dimensions, what we have to do, create m window on the screen, one for each dimension, and the m dimension value of a record are mapped into m pixels at the corresponding position in the window, and the color of each pixel reflects the corresponding value. So you can means represent like a dark one is higher value and a smaller one having lower dim things. So it can be also laying out in the form of circle segments. So to save the space and show the connection among multiple dimensions, space filling is often done in the circle segments. So you can see here one record can be represented of different dimension in circular way, and arrow direction will show means how they are correlated. So if we see in this one, so either it is correlated means related with positive correlation or negative correlation. So array shows the things. So this record is, we can say this is positively correlated. This one is negatively correlated with respect to the some other dimension. In a similar way, like geometric projection visualization technique may be like visualization of geometric transformations and projections of the data. Method like direct visualization, scatter plot matrices, landscapes, projections pursuit techniques. It helps users to find meaningful projections of multidimensional data. It cross-sections views like hyperslice and parallel coordinates. These are the geometric projection visualization techniques. So direct with data visualization, you can see a scatter plot matrices like with different variables, how they are correlated, the scatter values of each variables like longitude and longitude. They are correlated like this, longitude and latitude. There is no correlations. So in this way, we can measure how they are correlated with in different dimensions. We can also draw landscapes. So a visualization of the data as perspective landscape. The data needs to be transformed into 2D spatial representations, and we can see how means peak and then slides. In this way, we can draw the data points. Next one is parallel coordinates. So in this method, what we have to do, we have to draw n equidistant axis which we are parallel to each other on the screen axis and correspond to each attributes. So each lines are corresponding to each attributes, and the axes are scaled to minimum and maximum range of the corresponding attributes. Each data item corresponds to polygonal lines which intersects each of the axes at the point which correspond to the value for the attributes. Okay, and we draw the lines. The complete line show the one record and how they are means at the different dimension. What is their actual position on that we can do. In this way, we can draw the parallel coordinates. In a similar way, we can measure similarity and dissimilarity of the data set. Similarity means numerical measures of how alike two data objects are, and if the value is higher when objects are more alike, and it's often fall in the range of 0 to 1. Dissimilarity means like distance. Numerical value measures how different two data objects are, and the distance is lower when objects are more alike, and minimum dissimilarity is often 0 and upper limit varies. Proximity refers to a similarity or dissimilarity, means in the range of that certain particular point, how they are arranged. So suppose we have data matrix like n data points with p dimensions. We have two modes, and we can calculate the similarity matrix by calculating the distance between each points. Okay, so this is the lower triangular matrix or upper triangular matrix. And proximity measures can be done. So we can take two or more states, that is red, yellow, or blue, green. So method one is sample matching. So suppose we have m number of matches and total number of variable is p. So p minus m by p will be the proximity measure for that. And method two, use a large number of binary attributes, create a new binary attributes for each of the m nominal states. In this way, you can see how in object I and object J we have contingency tables for binary data. So 1 to 1, that is q number of points. 1 to 0 we have means r number of points. In a similar way, 0 to 1 s number of points, and 0 to 0 t number of points. We compute the distance measures for symmetric binary variables. We compute the distance measure for asymmetric binary variables. Then we compute the Jaccard similarity, like q upon q plus r plus s. So in this way we can compute proximity or similarity or dissimilarity. How to standardize numerical data using Z score, that is x minus mu by sigma, where x is the data point, mu is the population mean, and sigma is the standard deviation. So raw score, suppose x is the raw score, that too is to be standardized. So we means take the difference between raw and population mean and then divide with standard deviation. This will give you the normal value for the that particular raw data. Alternate way to standardize the things is calculate the mean of absolute deviations and then divide with that. So distance we can compute in various ways, like Minkowski distance. It is a popular distance measures. So you can it can be computed like this can also be called HH norm. Okay, so you take the difference of two data points. Uh, Square means if second norm we are calculating, then we can say that square them and then add all the data points and then take the square root. If hth norm we are considering, then we have to take the difference between the data points and then take the h power h for each data point and then take the hth root. Okay, so there may be the property like if distance is 0 greater than 0 for different samples for different records, and for the same records it is 0, then the property is positive definiteness. If distance is equal, then symmetry. If the two means triangular inequality, it should also follow. So this is the property of norm also. So it should be positive definite, it should be symmetric in nature, it should follow triangular inequality, means the sum of two edges is always greater than sum of third edges. So the distance between 2 points is always greater than distance between some point means I and j. So distance that satisfy this property is a metric. If h is 1, then that distance is called Manhattan distance, where we take only the absolute value and then do the summation. If h is 2, then that is called L2 norm, that is equivalent to equality and distance. Okay. In if h is infinity, then Sutramam. Okay. This is the maximum difference between any components of the vector. So it can be computed as a maximum of, means we take the difference and the maximum difference is the value for that, L infinity. So this is the example. Suppose we have two attributes 1 and 2, and we have 4 points x1, x2, x3, and x4. So in this way we can draw, means distance, we can compute the distance. So distance between 1 to 1 is 0. Distance between 1 to 2 is 5. Then we compute L2 distance. In this way we can make that matrix of L1, L2 and supreme. Next one is cosine similarity. So a document can be represented by thousands of attributes, and each recording the frequency of a particular word, that is in a phrase. So we can measure the cosine, like we take the two dot product between distance and magnitude of that distances. So this will give you the cosine similarity between the things. So major task in data processing like data cleaning, data integration, data reduction, like dimensionality reduction, data transformation and data discretizations like normalization and hierarchy generalization. So data cleaning. So data in the real world is dirty. Lots of potentially incorrect data we have. That is instrument faulty. That may be the due to instrument faulty, human or computer error or transmission error. So it may be of incomplete also. So lacking attribute values, lacking certain attributes of the interest, or certain containing only aggregate data. It may be of noisy types. It may be of inconsistent type. It may be or intentionally we make the error. So we have to clean these type of things from the data. So incomplete or missing data is always not available. That is, many tuples have no recorded value for several attributes such as customer income in sales data. Missing data may be due to equipment malfunctions, inconsistent with other recorded data, and thus deleted. Data not entered due to misunderstanding. Certain data may not be considered important at the time of entry, not register history or change in the data. So missing data may.
Hello. Hello.
Hello. Sir, you are not audible. Hello. Yes, sir, you are not audible. Am I audible? Hello.
By
Hello, sir. Hello.
boundaries. So the
Hello. Yeah. Hello, Mukesh, sir. Hello.
or regression technique you can apply. So smooth by
Hello.
fitting the data into regression functions, or
Hello,
you can
Mukesh,
do the
sir.
clustering, detect
Am I
and remove
audible?
outliers. You can also
Yes, ma'am, you are audible.
hello.
Yeah, Mukesh, sir, you were not audible from last means 2 to 3 minutes. You were not audible, and your screen is now also not visible right now.
Hello. Hello. Hello,
Hello,
ma'am.
can you hear me, sir?
Yes, yes, yes.
Sir, I'm saying that, sir, PPT is not visible, and from last 2 or 3 minutes, sir, you were not audible also.
Is it okay? Okay, well, let
Yeah,
me share
now it's
again.
okay.
Okay.
Now it's okay.
Is it okay now?
Yes, sir.
Okay, okay. So actually, I was discussing about how to handle, how to clean the data, how to handle the missing value, and how we will handle the noisy data. So noisy data may be of random error or variance in the measured variable. So it may be due to incorrect attributes value, or like faulty data collection instruments, data entry problems, data transmissions problems, technology limitations, inconsistency in naming conventions. So other type of data problem may be like duplicate, if we have duplicate records, in incomplete data and inconsistent data. So how to handle these noisy data? First method is binning. So what we will do, first sort data and partition into equal frequency bins. Then one can do by smooth by bin means, or a smooth by bins, or a smooth bin median, or a smooth by bin boundaries. Okay. Another method is regression. So we can do smooth by fitting the data into regression functions. Another method is clustering, that can cluster the data, and if any outliers are there, then you can remove that outliers. Then combine computer and human inspections, so detect suspicious values and check by the human. So in this way we can remove or handle noisy data in the data sets. Next one is data cleaning as a process. So data discrepancy detection, like using metadata, check field overloading, check uniqueness roles, consecutive roles, rule and null rule. Use commercial tools like data scrubbing or data auditing tools. We can combine various data and do in data integrations. So data can be integrated with from the multiple sources based on the schema integration, like customer ID is equal. Identify real world entities with multiple data sources and detect and resolve data value conflicts. So So in this way, we can do data cleaning, data merging. If we have missing value, then we can impute using various methods. Then we do the correlation analysis based on chi-square test, like observed minus expected square divided by expected. If the larger value of chi-square is, the more likely the variables are related, and the cells that contain the most to the chi-square value are those whose actual count is very different from the expected count. So correlation doesn't imply causality. Means number of hospitals and number of car theft in a city are correlated. Both are causally linked to the third variable, population. Okay. So this is the examples of chi-square calculation. Like suppose we have like science fiction, play chess, not play chess, some, and based on the in the square, in the small bracket, we have actual one, and 250 is the expected one, which observed, and 90 is the expected. So we take the difference between both. Wait a minute. हाँ पढ़ना सही है। कंप्यूटर लेके गए, छोड़ने में हो गया, पर टेबल छोड़ दिए, कुर्सी चेयर सब छोड़ दिए, फैन छोड़ दिए सब। हाँ थोड़ा आधा घंटा बाद। हाँ हाँ ठीक ठीक। हाँ बस कंप्यूटर लेके गए, प्रिंटर लेके आए हैं, कंप्यूटर लेके आए हैं, और एक शीट बनी का है प्रोजेक्ट का। कंप्यूटर देख लीजिए। ठीक ठीक। Okay. So we take the difference between observed and expected, and do the square and divide the number of samples, means expected. So in this way we calculate the correlation, means chi-square calculation correlation. In a similar way, we can compute covariance. So covariance is similar to correlation, and this is the formula for that. Covariance between A and B will be the expected value of A minus A bar into B minus B bar. Okay, so means we have to take the average of one attributes, and that take the difference between actual one with average and divide with hints. If covariance of AB is greater than 0, then A and B both tend to be larger than their expected value. And negative covariance means if it is less than 0, then A is larger than its expected value, B is likely to be smaller than its expected value. If covariance is 0, but the converse is not true, okay, that is independence case. This is the example for covariance. In a similar way, we have data reduction strategy. So data reduction means obtain a reduced representation of data set that is much smaller in volume, but yet produces the same result. Okay. So why it is required? So data or database may store terabytes of data, and complex data analysis may take a very long time to learn on the complete data set. So data reduction strategy, it will remove unimportant attributes from the data sets, and the methods we can use is wavelet transform, PCA, feature subset selections, features creation technique. Okay, means if the features are not important for the modeling, then we can neglect that features or remove from there. Okay, or we can take different transformations of that features, like PCA. by applying the PCA techniques. Next one is numeric reductions. It means some simply call it data reduction based on regression and log linear models, histogram, clustering and sampling based, and data cube aggregation and data compression also. Another technique is data compression. So by using these things, we can reduce the data. So dimensionality reduction may happen due to curse of dimensionality. So what is curse of dimensionality? Curse of dimensionality means when dimensionality increases, data becomes increasingly sparse, and density and distance between points, which is critical to clustering outlier analysis, become less meaningful, and the possible combination of subspecies will grow exponentially. That is the case of curse of dimensionality. One general case is number of sample is very less with respect to number of features. Then that case is curse dimensionality. So in this case, we have to reduce the data, okay, or dimensions. So we can reduce the dimensions so that the specific problem may be reduced. Next one is the dimensionality reductions. Like it avoids the curse of dimensionality. It helps to eliminate irrelevant features and reduce noise. It reduces time and space requiring in data mining or data analytics. It allows easier visualization also. Like the techniques we can use wavelet transform, PCA, and supervised or nonlinear technique like feature selection techniques we can apply. These are the things. Next one is PCA, find the projections along the axis or along the principal components. That is the it captures the largest amount of the variation in data, and the original data are projected onto a much smaller space, resulting in dimensionality reductions. So suppose in x1, x2, these are the scatter plot of the data, and after finding the principal component E, we are transforming these data points along with this. Okay, this is a new space for the data set. Original space is x1 and x2. New space is e1. So along with e, we take the projection of data, and that is the these are the methods to apply in the PCA, principal component analysis. So steps involved in PCA is for a given data set having n data vectors of n dimensions, where find the k less than n, that is orthogonal vectors. Means we have to find the principal component that can be best used to represent the data. So what we have to do, first of all, normalize your data set. So each attribute falls within the same range. Computes k orthogonal unit vectors, that is principal component. Each unit vectors is linear combination of k principal component vector. And the principal components are sorted in order of decreasing significance or strength based on the eigenvalue. Okay, and so what we will do, we calculate the covariance, then we apply the eigenvalue and eigenvector, and the eigenvector will be correspond to principal component, and based on the eigenvalue, we sort the things, and the higher eigenvalue means variation is high, that contains the more information, higher information. Okay, along with that axis or principal component, we take the projections of our data points, and we select that this is the first principal component, and it works on the numeric data. Another method is subset selection. So another way to reduce dimensionality of data is subset selection of the features. So based on the different criteria, like we have redundant attributes, so duplicate much or all of the information contained in one or more other attributes, that is purchase price of product and the amount of sell tax paid. Irrelevant attributes we can also remove, that contains no information that is useful for the data mining task at hand. Another approach is heuristic approach. So here for feature selection we can apply various statistics technique to reduce the things, means by making some assumptions. Suppose we are applying means doing the classification tasks, means cat or dog classification, and we are trying to reduce the features. So we can assume like suppose this is a two-class problem, and our assumption is for any features, the mean value of each class is same, and alternate hypothesis will be mean of each class is not same. Okay, so we can differentiate, or our model will be based on the differentiation between the what is the strength of that differentiations, the how, so that we can differentiate the classes whether this is cat or dog. So what we will do based on our
Hello. Hello, sir. Mukesh, sir. Am I audible? Yeah. Am I audible to dear participants?
Yes, madam, you are audible.
Okay. So I guess there are some network issues from the expert's end. We are not able to hear him. Hello. Am I audible? Please confirm.
Yes, ma'am, you are audible.
Okay, there is some network issues from the speakers and he is rejoining soon. So we request all the participants to please hold on until then. Thank you.
Sorry, internet was broken actually. So next method is numerosity reduction. So in that, what we will do, reduce data volume by choosing alternative smaller forms of data representation. It is based on parametric method like regression. So in that, using a data fits some model, estimate model parameters, store only the parameters and discard the data points. Okay. So in this way, you can reduce the data. That the representative content to means represent the all the data points. We can only will keep that parameter. In non-parametric methods like don't assume the models, major families like histogram, clustering, and sampling. So in parametric reduction, data reduction, regression using regression and linear log linear models. So you can apply linear regression like data model to fit a straight line. Often uses the least square method to fit the line. In multiple regression, allow a response variable y to be modeled as a linear function of multidimensional feature vector, and in log linear model, approximate discrete multidimensional distribution. So this is the regression analysis. What we will do, it is a collective name for techniques for the modeling and analysis of numerical data consisting of values of dependent variables, also called response variable or measurement, and of one or more independent variables. That is called exploratory variables or predictors. The parameter is estimated so as to give a best fit of data, and most commonly the best fit is evaluated by using the least square method. Okay, so what we will do here, suppose this is a scatter plot of data points. Okay, and in that we have to fit a line. So what we will do, we compute the distance between actual one and predicted one. So suppose that's x1 point, y1 is the predicted value, actual value, and y1 dash is the predicted value. Okay, so in least square method, what we will do, we compute the error or distance between them, or take the mean square error, try to minimize that error for all the points. Okay, so this is the optimization. Our aim is to reduce that particular, minimize that error. Okay, so during reduction of this error, we will achieve a base fit that the error correspond the value correspond to the minimum error will be the optimal value for that line. Okay, so in this way we can compute the weight and bias for that particular line. So in linear regression, what we learn, y equal to wx plus b. Here two regression coefficient w and b we have to optimize using least square methods. Okay, and multiple regression b1, b0, b1, b2, bn, and we in a same way we can apply methods to find the optimal for the in linear approximate multidimensional distribution, estimate the each point.
Hello. Yeah, sir, can you hear me? Your voice is breaking, sir.
From the
Hello?
mention of
So your
use
voice is
time
breaking.
and reduction for data smoothing. Another method is histogram analysis. Divide data into buckets and store average for each bucket based on partition rules like equal width, equal bucket range, and equal frequency based on equal depth. Another method is clustering. So partition data into cluster based on similarity and store cluster representations that is centroid or diameter only. Okay, centroid and diameter only. It can be very effective if data is clustered, but not if the data is simmered. Can have hierarchical clustering and be stored in multidimensional index tree structures. There are many choices of clustering definitions and clustering algorithms. Cluster analysis will be studied in different uh, slides. We can do the sampling. Sampling is obtaining a small samples of S to represent the whole data set N. Allow a different algorithm to learn complexity that is potentially sublinear to the size of data. To the representative subset of data, some simple do the sample random sampling of adaptive sampling method, that is sampling. In which way we do the these are the methods. So in simple random sampling, this equal probability of selecting any particular item. Suppose we put a positive plus and negative, so we want to do the sampling for that. So equal probability of each class we will select from there. Sampling without replacement. We take the samples and suppose we are selecting the samples for training data. So what we will do, object is selected from the main set, that it is removed from the population, that cannot be kept there. Sampling with replacement, a selected object is not removed from the population, then this is the method for sampling with replacement. Stratified sampling, partition the data and draw samples for each partition proportionally, that is approximate the same percentage of the data. Okay, and suppose we are means 5-fold we are considering. So for each fold we will select in the same proportion. Okay, so these things can be useful in skewed data. Okay, suppose we have very less amount of some class and very large amount of some particular class, then we select data in that particular way. Means suppose we are selecting data, means each fifth data we are selecting, okay, for the training samples. So each fifth samples it will extract from the data set. So in this way we do the stratified sampling. We can also do the data transformation, like it is a function that maps the entire set of values of a given attribute to a new set of attribute replacement values. Subject to each old value can be identified with one of the new values. Methods we can apply here is smoothing, remove noise from the data, and attribute and feature construction, that is new attribute constructed from the given ones, and based on the aggregation or summarization, and to the normalization also, that scale to fall within a smaller or a specified range based on mean mass normalization, where what we will do, suppose x is the original value and so x minus x min divided by x max minus x min. In this way we can do the mean mass normalization. Z score we have seen like x minus mu by sigma. Normalization by decimal scaling we can do. In C we can discretize our data. So this type of transformations we can apply on the data sets. Okay, so we will take a small break here of 10 to 15 minutes, and then we will start the next session. That is hands-on of ADA using Python. Okay. So we will meet at 11:45 to the new session. Bye-bye.
Hello. So dear participants, there is a break of 15 minutes. So we request not to leave the platform. Please remain connected and join by 11:44. Thank you. Hello. Hello, Mukesh sir. Hello. Am I audible? Please confirm.
You are audible. You are audible.
Okay, Mukesh sir, can you hear me? Okay, so I guess there are some network issues. I will get back to you soon. Thank you.
Hello, hello, hello.
Yes, sir. Yes, sir, you're audible now.
Yes. So now we'll start the hands-on session for the same that we have discussed. I know, I think basic Pythons and NumPy, Pandas, you all know. So we'll start how these things can be done using Panda library and what are the some UDF you can design for that. Sharing slide. Okay. I think this notebook is visible to all of you.
Yes, it's visible.
Okay. So in this notebook, we have
Sir.
taken different data types, data sets, right? Related to books, related to unemployment, related to some divorce, salaries, okay, and using Pandas library. So here, this is the path location for the data set. So and we have imported all the packages related to this analysis like pandas and we have imported panda as pd we have imported numpy as np and to visualize things we are going to use snc and matplot library. Okay, so in this way you can import any library in python. So simply we will go on the just you can write like install any package like pandas.
Hello. Hello, sir. Hello.
Hello. Yes, sir, you're audible, sir. Hello. Hello, sir, you're not audible, sir. Hello.
5 columns like name, authors, rate. Okay, is it visible? I think screen is shared.
No, no, no. It's not visible.
Wait. Yes, ma'am. Yes, ma'am. I just. Now is it okay? Actually, here net problem is there, ma'am. So that's why we are disconnecting again and again. Okay, I will check again and again now. Okay. Okay, ma'am. Okay. Hello. Is it okay to all of you? Okay, so suppose in this data frame, book is the data frame, in that we have 5 columns. So columns also you can easily write like books.
Hello, sir.
Yes, yes, please.
Sir, can you please share the dataset link so that we can follow along with you?
Yes, yes, I will share this notebooks and link also. Okay,
Like in the chat
or
box right
I
now.
can share the things. Okay, I will share. I will share. Okay, so you can also check like name, author, rating, years, and genres. Genre are the attributes or features in these particular data sets. Okay, so these things you all know. So we have data URL like URL books, unemployment, URL divorce, and salaries. These are the data frames, and we have these things. We just want to print with in this way, like what are the. Okay, now getting to means how what is our data set. Initial explanation. It will only select 5. Values, values. I'm sharing my notebook again. Please let me know when it is disconnected. Okay. So just go to there. It will give you the means what are the functions, what are the methods, means how they are defined, what the parameter it will take. Okay. So in this pop-up window you can see. So method value counts, normalize, literal false, sort, boolean, ascending, means everything you can provide in this one. So it returns series containing count of unique values and the resulting objects in descending order, so that the first element is the most frequent occurring element, excluding any value by default. Okay, and these are the parameters, all the things, everything you should have, but with examples also. So suppose this is the data frame. So in this three is comes two times, one is comes one times, two is comes one times, and four is comes one times. Okay, so in this way we can use. Okay, so when we run this cell, so in continent, in this data set, unemployment data set, we have one field continent. So in continent Africa is of unit type, and that comes under 53 times. Asia is 47 times, Europe 39, North America 18, South America 12, and Oceania 8 times. Okay, so means what are the unique values inside that column, and how many times that unique value comes, what are the frequency for that. In this way we can easily count using value counts. Okay, now the same thing we can visualize using, we can means complete data is that based on the histogram inside like. So what will be the x label, what will be the y label, and what is the title of this graph, and then we can do the plot dot show. So when we run, so you can see the bin size increases. Okay, so all the distributions means all the data sets is binned with say 5, and then we count the frequency of that particular things in that particular bin. Okay, in this way histogram we will study. So by default it was 1. Okay, so from this histogram you can observe that this graph is not fully normal curve. This is means skewed with in the right direction. So right is skewed graph is there. Okay, so by observing this graph we can see that mean is not the appropriate measures to do the next things. So here we can apply median. Okay, so suppose we want to change some data types or detect data types, so simply we can do means the data frame dot d types. It will provide you the data types of all the columns present in the data frame. Suppose we want to change the data frame types. So simply you go to that column means unemployment 2019 and dot as type int. Okay. So earlier it was unemployment dot int. Okay, when I run. So here you can see the country code is of object type, country name is of object type, continent is of object type, and these are the years 2010, float type, float type, float type. Everything is of float type. Okay. Now what we have done, we have just updated that this column. The type of this column is of integer type. Okay, and then print. So here you can see the type is changed now, right? So in this we can change or transform any data frame based on our choice. Here we can validate continents like define a series describing whether each continent is outside of Oceania. Okay, so here what we will do, we will select the continent, we select the means which is inside Oceania, and then we apply the knot. So the rest things will be applied to that, and this will give either true or false thing. And this series we will provide, this list we will provide to the that data frame. Okay, inside this data frame we have selected this one. So if we print this one, it's having only 0 or 1 kind of. Okay, so when we run, you will get all the codes, all the country name, all the continent name, continent rest means without Oceania. Okay, like rest things will be here. Okay, so in this way you can do the simple processing. You can also validate the range, print the minimum and maximum unemployment rates during 2021. So it will print so minimum and 2021 maximum. So by using min max function, dot min will provide you the minimum value and dot max will provide you the maximum value of the any data frames for particular column. And in this way, in a square bracket, we will write the column name. Okay, so it will select that particular column, and then on that particular column or particular attributes, what is the minimum value, then we will apply this one. Okay, now we will draw the box plot on the same column. It's broken down by the country name. So in this x-axis the year will be there, and y content means continent will be there. So when we draw, so here you can see the box plot. This is the minimum value. Okay, and this is the first quartile, this is the median value, this is the third quartile q3, and this is the max value. Okay, and now mean plus minus 1.5 iqr. If the value is these 3 points not in that particular range, it means that these values are outliers. So you can remove by selecting the index of these things. So just check the condition with 1 point means min plus minus or max plus 1.5 IQR, min minus 1 plus 5 IQR, and then just select the indexes of the data set that will be the outliers. Or okay, so for different continent you have the box plot, and in this color continent you can see what are the outliers or what are the points that is outliers. That outliers you can remove from the data points. Okay, by selecting the index. Next thing is data summarization, how we will summarize the data. So this is the data type. So this one is the data. So here you can see we have country code, country name, continent, and in 2010 means 2010, what are the value for unemployment. These are the statistics of these things. Okay, so print the mean and standard deviation of rates by the year. So suppose for 2019 we are calculating what is the mean and standard deviation. So just what we have to do, we have to select the data frame, and in that data frame select that particular. Okay, and then apply mean. So what will it will do means it will take the mean and standard deviation of that particular column. Okay, so here you can see mean is the 7.24 and standard deviation is 5.69. Suppose we want to do based on the continent, we want to do the we want to calculate the mean and standard deviation. So for particular continent, suppose in Africa, what is the mean and standard deviation? In the earlier code, earlier line, earlier cell, we have calculated mean and standard deviation of complete column. Okay, but now here what we have to do? We have done the calculation of mean and standard deviation using by continent, by continent. Okay, so what we will do? We have to do the group by with continent, and then select that particular column on which we want to calculate the mean and standard deviation. Okay, so it will print yearly mean and standard deviation group by continent. Okay, so in Africa the mean is this one and the standard deviation is this one. In Asia mean is this one and standard deviation is this one. In Europe mean is this one and this one. Okay, so see the difference. Suppose we want to apply on complete column, then we can simply give like this. If you want to apply on some specific thing, means we have to group something, and then on that particular group we have to calculate the mean and standard deviation. Then you have to do this thing. Okay. In a similar way, this code is same. Okay. Here is the mean. We have to hash support 2011. We have to add it. So we are selecting the, we have done the group by continent, and then select the year, and then aggregate function we can apply. Okay. We also apply the means named aggregations we can do, means what are the mean, we can give the name, some name to a different name. Okay, like mean rate of 2021. Okay, mean rate at this one. So it will give you this thing, mean rate of 2021, mean rate of standard deviation of this one. Okay. And the same thing we can visualize, like unemployment x axis will be continent and y axis will be 2021, and error bar if this one. So it will draw bar plot we are doing, create a bar plot of continents and their average unemployment. So you can see here the average unemployment for each continent. Next thing is so these are the basic thing we can do, and we have a very nice documentation of any library in the Python. So and it's changing with time again. So we cannot rely on the simple code. So for that particular Python, these things will work. Suppose we are selecting Python 2 point something, so this may not be work. Okay, so for so it's changing with time. So you go with the documentation, and based on that documentation we can modify the code. Or if you want to run these codes, then you have to install that particular Python on that system. So you have to take care of these things. So here we have loaded the plain data set. Inside that we have airline, date of journey, source, destination, route, departure time, arrival time, duration, total stops, additional info, and price. So these are the columns. Okay. Here we want to check that is there any null value in each column. So simply we have to write the data frame, and this is the function. It will check data frame dot is null is an alias for data frame is na. Okay, it will detect missing value, and it returns a boolean same sized object indicating if there the values are na values such as none or numpy dot nal get mapped to true values. So everything else get mapped to false value. Characters such as empty string are not considered na. Okay. So these manipulations you have to do in your data set. If your data set is having these type of strings, then you have to remove that one. Okay. So in this way you can use things. So df is na. It will give you the false, false, true, 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 false. It means that true means there is a na value. Okay. So you can use the examples. So what we have done, we have just, if we print this one, it will print all the matrix with 0 and 1, or means true or false. Okay, and that matrix thus we have applied on that sum. So if there is any none value, means non-zero value, that will be sum. So that one will be sum. Okay. So here line 0, there is no missing value. Here only in root one missing value is there. So sum is 1. In total stuffs we have one missing value. then this is the value is 1 here. Okay, so in this way we can summarize or we can check whether there are any null value in column. Count the number of missing value in each column. Simply use data frame dot isNA dot sum. Find the 5% threshold. So it will give you the 5% threshold. We can also apply some filter on that. So suppose this is a 5% threshold. So plain is NA dot A means if means the length of plane and 5% of that thing. So if there is that uh, this threshold is applied less than that sum, then only we can select, otherwise no. So if missing value is more than suppose total length is 100, so if missing value is more than 5, then that row is not selected. Okay, and drop missing value column below that threshold. So now after selecting, if missing value is less than that threshold, then that will be dropped out. Okay, so this will give you the list of whether is true or false. Means if the threshold means that planes or missing value is more than 5, less than 5, then this will contain 1, otherwise 0. After, so drop NA function, just give that condition means list that thing place is true. What in place will do, you can see here. And you can also study means what is the meaning of in place. It is a boolean. By default it is false. Whether to modify the data frame rather than creating a new. So if we are providing true, then our data set size may be smaller. Means if we remove some rows, means if the missing value is less than 5, then that row will be deleted from the data frame. Then we have to do in place equal to true. Otherwise, if we give the false, then at that point it will be means null value. Okay, now we will print. So you can see earlier it was this one, now this is this one. So missing value with less than 5, that column, that things will be removed from the data set, and now we have only 0. Okay, so first method, how to handle the missing value. Just we will delete the number of that instances or call means samples from the data set. We can do by this way, or manually we can do means by looping, by doing the for loop we check one by one, and we can remove that thing. Or suppose you have matrix, so you matrix is very fast with respect to the loops or anything. So in data analytics things, this is the beauty of these things. So you can directly on matrix you can do the computation. There is no for loop we can use here. Okay, so in this way you can uh, remove missing value rows from the data set. Next one is check the value of additional info column. Okay, here and create a box plot of price by airline. What we have, no info 8344 in flight meal not included, this one this. So for additional info there is no info on that. Okay, one longer layover 19 rows are there inside this one. Change airports 7s are there. Business class 4, no info. 3, one short layover 1 times, red eye flight 1 times, 2 longer layover 1 times. Okay, and then we do the box plot where x is the price and y is the airline. So based on these things we will draw. So you can see performing this sale we will get this answer. So Jet Airways price you can see. Okay, so in this way we do the analysis for the means Indigo flights or Spice Jet. Okay, to jet. These are the smaller one or cheap flights. Okay, and you can see in this one jet airways business class business how the price is fluctuating, and one instance was there where price was 80,000. Okay, so whether it is outliers or not, you can check easily. Okay, so out of these points in Indigo, the price fluctuations you can see and how they are means fluctuating the price. You can also observe so from the normal price to outliers on. So how to impute missing value to calculate the median plane ticket price by airline. Okay, so there are many methods like mean, median. So here we are using median. So on price column means we are taking the plain data set and we have done the group by with airline. Okay, so that particular airline, suppose Go Air is there, and inside the Go Air, what is the price? The we take the median of that price, not the global one. Means not global means here all the flights, all the airline prices, median of all the airline. So we are taking the individual airline and we are taking the that median value of individual airline. Okay, and we are replacing the missing value of that particular airline with their corresponding median value. Okay, so here median value we have, you can see this is a median value for each and every things. Okay, now we want this value means the missing value should be replaced with this one. So for Air Asia this value should be there, for Air India this value should be there, for Go Air this value should be there. Okay, so what we will do, so this list that median value for each airline, this will be converted to dictionary to map the things with airline. Okay, so we have created with the dictionary, any logic you can write, but here we have done in this way. So here we have converted this list, selected list, into the dictionary. Okay, so airline price dot dict, it will give you like this Air Asia. So data frame will be converted to dictionary here. So this one Air Asia is this much, Air Asia in this way. So this is the key and this is the value. This is the key and this is the value. This is the key and this is the value. Okay. Now we want to map if is there any missing value in airline Air Asia, then that missing value will be replaced with this value. Okay. So how we can do? So we have selected the price fill NA with plain airline dot map price dictionary. Okay, so map value, what it will do, map value of series according to an input mapping or function used for substituting each value in a series with another value that may be derived from a function, a dictionary, or a series. Okay, so means there is no confusion for that, means what this will do, what this will do. Okay, everything you can see. Okay, so there is nothing to remember, just should have a very good hands on and you can use the. Okay, so what we will do, we will map on this list on that particular value. So you can see there is no missing value now, and that will be replaced with this. Next thing is converting and analyzing categorical data. So finding the number of unique value. Filter the data frame for object columns. We have object columns like if you see things dot info or d type, you can also see d types. So it will give you the types of all things. So these are the of object type. Only price is of integer type. Okay. Now we have select data types with which is of object type. So we have just filtered that plane. So only we have filtered. Okay. And next thing is for column in non-numeric terms, that is non-numeric is the only of object types. Okay. What we have to do? We have selected that this function unique. It will select the number of unique things, return number of unique element in that object. Okay. So number of unique objects in airline column is 12. So we have 12 types of airline. Okay. Number of unique value in date of journey column, so 44. So in this way you can do anything. Suppose we have a list of category like short haul, halt, medium, long halt. Okay. And based on this category, we want means create the short flight like 1 hour, 0 hours, 2 hours, 3 hours, 4 hours. So these are the we created. Create mean flights like this much and this much. Okay. Adding duration category to that frame. How we can do? So conditions is plain duration that contains short flights. Okay. So if this contains short flight like 0h, 1h, 2h, 3h, 4h. So after applying, create conditions for value in flight category to be created. Apply the condition list to the flight category. Then select, apply that conditions, and then flight category, report extreme durations. Okay, and then we plot that things. So in short haul, you can see the count, medium, extreme durations. You can see. Okay. In this way, you can transform your categorical value in different things. So now with flight duration, first is preview the column and then remove the string character and split on space. Convert this to float data type. So using these functions you can convert. So if you want to see method is of this one, so is float. It will convert any type to float type. Okay, and then we draw the histogram for that. So in this way you can do these things. We can also add descriptive statistics. So on this, we want to add a column that will convert the standard deviation. So for each airline on price, we want to add a standard deviation. So what is the means the problem is what we want to do. So for any number of any airlines, what are the standard deviation? Air means what is the standard deviation? Okay. So what we will do, plane dot group by airline, then we select that particular column price, and on this price, what is the output? Okay, suppose we are not giving this one. What is the output for this line? Plane dot group by airline and price. It will provide you the list of value means price. We can directly say price in for that particular airline. So suppose in airline we have 10 values. Okay, so Jet Airways this will provide you the list of 10 values. Okay, now what is the aggregation functions we want to apply on that? So on that list we apply the aggregation function. Suppose we are applying sum, so that the sum of that particular list. Okay, suppose you want to compute mean, sum of that particular list, mean of that list. So here we want to convert a standard deviation. So mean of means a standard deviation of that particular list. Okay, I think you got the idea for that. So simply, but it will provide you an object or a list of the price items for particular airline, and after applying these transformations means lambda x, it will apply that list to means in x, that list is the input, and on that list we are applying the standard deviation. Okay, so suppose we want different things. You can also manage with weight. Same thing we want, so want to print, but here we will write dot variable. Std is not defined. Standard deviation is not. Okay, so that's why we have to write like this. Okay, so it will add one column standard deviation, and it also count the values. So in airline, total number of values is this much. So that list of the length of that list is 3849. Now on that list we have calculated the standard deviation. So I think you got the idea, means how, what are the things we can do on that list. Okay, so any functions we can write here, any operations. Okay, suppose I want to apply a standard deviation divided by mean. Okay, so solution is mean. So what we are doing, we will divide these things standard deviation with mean of that list also. So we can simply see, okay, this is the value. So my intention is to show you, means anything, any manual things you can do here based on your requirement. So just use transform function, and on this transform you can provide any function. This is the lambda function. So directly either you can use lambda function or any function you can use. Okay, simply you means define any function here. Okay, def abc, and your parameter is that list x. Only x we have. X is of type list, right? Now on that x we have to do, means suppose I want to do simply I want to apply length of x into 2, so that we can means easily uh, validate the things whether we are doing correct or not. Okay, getting my idea? So what we should be output? आउटपुट क्या होना चाहिए कि जो भी है ये है, दिस इज द लेंथ, just it should be doubled of that thing. Okay, so just implementing, and we are providing that function abc of is not defined. Lambda. See the output. See, we are doing the length into 2. Okay, 6 into 2 12, 3 into 2 6. What the idea? So anything you can do here. So here we have that list, and on that list we are applying any transformation, any computations we can apply. Okay, suppose for time series or anything, we want the mean value or median value of that, or anything, any computation we can do that is not already defined. Okay, so you can see here In this way, you can transform your things. Okay, I think you got the idea for that. In the same way, durations by airline. So just we have with respect to on durations, we are just looking the median. Mean also we have applied. So mean, median, and standard deviation we have computed. Now, how to handle the outliers? So how to identify the outliers? Suppose we have draw the histogram for that. So histogram of this data frame is like this. Now we want to describe means this function is used to give the statistical description of any data set. Okay, so this can be described like what is the count, how many things are there, what is the mean for that, what is the standard deviation minimum, what is the first key one means quartile, first quartile, second quartile, third quartile, and what is the maximum value. So describe functions will give you these things. Okay. So which column potentially contains outliers in price and duration? Wait, wait. Wait a minute.
Good morning, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. डुअल डिग्री में बच्चे नहीं दिख रहे हैं.
Hello, participants are requested to please mute yourself. Thank you. Hello. All the participants are requested to please mute yourself. Yeah, Mukesh sir, hello.
Sorry, man. So,
So you are not
okay,
audible. You were not audible from last 2-3
hello,
minutes. Yes, sir. Sir, Mukesh
hello.
sir, can you hear me? Hello.
Yes, ma'am.
So
Is
you
it
were
okay?
not audible. So you were not audible from last 2-3 minutes.
Now it's okay or not, ma'am?
Yeah, now it's okay.
Okay, so should we discuss again from here?
Yes, sir.
Is it okay to all of you? Okay.
Yes, sir.
So what we are applying means here I was explaining that suppose on price after doing the group by. So what we are means what is the result for that? This is the list of price. Okay, on that particular thing. On in that list, what we can means we can perform any type of operations. Okay, so what we have do, instead of doing a standard deviation, we just computed that we want to apply this function, means length of that list x into 2. Okay, so any UDF, user defined functions, we can apply length. Okay, so in this way we can do. So you can see here, you can see the output also. So this is the length that is giving the system by default, and what we have written the logic on that length, we are applying the value that list into 2. So simply we can do, so any transformations you can do here. Okay, in the same way we have computed median. So this is the median for that particular airline. Jet Airways 13, Indigo 2, Air India 15, multiple carriers 10, SpiceJet 2. Okay, and then median mean also we have computed. So mean we have computed price, destination mean, group by destination, and then we have selected for that destination, we have selected the price, and then we have transformed this function. We are going to compute the mean of that particular list of price. Next one is handling the outliers. So suppose this is the data set. We want to describe the any particular column or any particular attributes of the data. Then we can simply write planes, that data frame name, and then select the particular column. Okay, provide this information to the data frame. This will give you the column things, and then describe. Okay, so it will give the this much of information, like what is the count, total number of rows present in that particular column, and what is the mean, what is the standard deviation, what is first quartile, second quartile, third quartile, and maximum value. So how we can remove outliers? So here selected the third quartile 75% and first quartile, and then we compute IQR, that is Q3 minus Q1. Okay, this will give you the IQR value, and then we, so upper range will be Q3 plus 1.5 into IQR. Okay, so this is the upper range, and lower range is Q1 minus 1.5 into IQR. Okay, so this will give you the range. So out of this range, that value is considered as an outliers. Okay, so now this range we will apply on that particular column. So suppose we have a price column, price of plane, and if the value is greater than lower, if the value is less than upper, then that value is useful and without outliers. So there is no outliers in this particular range. So this value becomes this one now. And if we do the, again we describe, means check the descriptions, we can see the how, but now the count will be changed. Okay, earlier it was earlier it was okay, earlier it was 10,682. Now we have 10,586. Okay, so some more than 100 points are outliers. Okay, so mean will be changed, standard deviation will be changed, quartile also it will be changed. So in this way you can remove the outliers. Okay, next thing is how to find the relationships in data sets, the pattern over time, like import data. So suppose we have this data set, So here we have given this one date past data set. So these are the things. So the type of these things you can see. This is the type of date time in nanosecond. Okay. So these columns are converted to the data means time stamp, right? Date time. Now up to data time, date time. So simply this is the functions to convert any columns to date time. This function convert a scalar, array like, series or data frame or dictionary like to a panda date time objects. Okay, it will change the types of data type, means data type of any column. Okay, so now we select define the marriage year column. So we have selected the marriage date dot dt dot year. So only it will give you the year for that. Now we have computed means calculated the line plot. So when we click, so x is marriage year and y is number of kids. So create a line plot showing the average number of kids by year. Okay, so in this way you can draw. In a similar way we can compute correlations. So if we visualize the things scatter plot, we draw the scatter plot of these things. So this is the scatter plot, marriage duration and number of kids. Now visualize multiple variables. So variables are income and marriage duration. Income and marriage duration with different things. Okay. So this is the means correlation between these things. Pair plot we have done for income and these things. Okay. So income women to marriage. In this way, you can do the pair plot. We can see the relationship between income women and marriage duration is not so strong one. You can also get a sense of the distribution of both variables in the upper left and lower right curves in this one and this one. Okay. In this one and this one. We can also do the factor relationships and distributions. So you can see the columns now. We selected calculate the age at marriage and create the scatter plot like that. So for different category education in, and this is the income, okay, on different range. In a similar way, we can draw different kinds of plots like violin plots. So what it will do. So here this point is its median or mean you can see, and inside that this is the box plot. So and you can see this tail part is how the things are outlier kind of thing. Okay, how means data are distributed, where how what are the spread of the data set, everything you can visualize in this. See the KDE plot. In the same thing KDE plot, you can we can show cumulative distribution function CDF. So in this way you can do what is the cumulative equal to what equal to 0 equal to number of kids, x-axis. KDE evaluation plus sci-fi. Okay, there is some error in that. So on the next data frame, this is the columns of salaries like working year, designation, experience, employment status, employee location, column size, remote working ratio, salary in USD. Okay, so if we draw, so this will look like this, and we should check the imbalance of classes. So on destination designation, it will means when we check the number value present in that particular class. So like data scientist, the this is the frequency, relative frequency. When we draw the cross tabulation, so it looks like data science is the most popular class and has a similar representations. Still, the other categories have quite different relative frequency, which might not be surprising given the target audience is data scientists. So if we do the cross tabulate with respect to job category and column size, so you can see here company designation, company size low, medium, and is for small, large, medium, and small. So, and for different designation, you can see how they are distributed. Okay, so this is the cross tablet. In a similar way, we can draw cross in job category and company size. So these are the things we have. Like another analysis, like we want to generate some new features. So extracting features from correlations, adding random dates and month in working year column, converting working year column to date type. So in this way, you can do salary without working year. Format is Y. Only we select year to date time. Okay. So we have selected this one. Generate random date and months. So we have selected numpy np.random.choice. In this range, we have selected random date and month. And then we create a new data frame with modified working year. So in this way you can do. Convert USD to INR. So current exchange value is this one. Okay. Now new salary will be this into this. And then we draw the, so here you can see the salary in INR and this the thing, uh, response date. This is the new column for that. Okay. Based on this, we do some analysis. So get the month of the response. We select the response that column and then dot dt dot month dot dt dot weekdays. It will provide you the weekdays and it will create a heat map for that. So correlation between different column means working and salary. So in weekdays, in monthly basis, salary, vesti, and working remote working ratio, how they are correlated. You can draw a heat map for that. Now next task is calculate the salary percentiles. So this function will give you the quartile. Just pass the means I want a 25% quartile. It means that 25% of the sorted data is lesser and more than that is greater than that. Okay, so it will give you the quartile. Now save the median and then gather the seventh mean third quartile. So everything is this. Now on different categories we have created the salary labels, create the salary range list, and based on this we compute the plot the count of salary labels at companies of different sizes. So for large, these are the counts, and for small, these are the counts, and for medium, these are the counts. So this line give you the entry level, mid level, senior level, executive levels. Okay. So in this way, by using pd.code to split out numeric data into categories, you can see that a large proportions of workers at small companies get paid entry level salary, while more staffs at median levels, okay, company are rewarded with senior level salary. So from here, you can more than the entry level having more salary than senior level at low and medium. Next thing is generating some hypothesis. So based on these things, we create the bar plot of employee location and salary to the hypothesis. Just employment status. Create a bar plot of salary versus company factoring in employment status. It will give it the. Okay, so these are the basic EDA of data using Python. Now, next one is next task is
Sir, can I ask a question here?
hello. Yes, tell me.
I have a doubt in this. Actually,
Yes,
you have
please.
shown
Yes,
some
please.
plots, right? You have shown some violin plot, all those things.
Yes, sir.
Yes, sir. If we are dealing with some imaging data for like
Hmm.
when we go for deep learning thing, so we are getting some output like for like accuracy, precision, F1 score, sensitivity, like that. We are getting output, right?
Okay. Okay.
So if we want to do this statistical analysis for that to prove our deep learning model is a novelty and prove some good accuracy, how to go for this Python thing for statistical analysis for that output set? Can you
Okay.
get
Means
what I'm?
okay. Your question is suppose we have applied deep learning models on some data set and
Yes.
it produces some results. Some results,
Yeah, we
and
are
whether
getting
this
some.
result.
We are getting some output as a value, right? Like
Yes.
0.99.
Yes. Yes. Suppose
Yeah.
is something.
Yes.
Or suppose we have some baseline models and we have new models, okay, and we
Yeah.
want to compare means whether our result is more means significant or not, right?
Yes. 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 Yes.
We have means 10 models or means 10 parameters
Yes.
inside our models, okay,
Yes.
and based on that parameters we want to check, right?
Yes.
So,
We are getting the output using this DL model as that
okay,
output
yes,
is
yes,
not
yes.
valid, sir.
Yes, I got your question, I think. So what we see means we have some baseline model. We want to compare our model is means how much good or not, or whether this is similar to that pre means earlier model baseline models, right? So this can be done using a statistical test, I think. So suppose we have two groups. Means group means one is baseline models and group two is our models that we have implemented. And we got the accuracy, means got the means performance parameters for that, and we have performance parameter of baseline models also.
Yes.
Suppose in both models we have 10 values, 10 things. Okay,
Okay.
and on 10 groups 10 things, and we have two groups, so our hypothesis will be like means the mean of or the performance mean of both model are same. Okay, suppose first hypothesis I build, that is null hypothesis, the performance mean of each model is same. Okay, and alternate hypothesis is the performance mean of both model is not same, means there is significant difference. Okay, so in two-tailed test, this type of assumptions you can build and you can apply. Suppose we have applied t-test, okay, we have computed t-value and p-value according to that, and in some confidence interval, suppose in 99% or 95% of confidence interval, if our value is greater than or less than that value, if p-value is less than 0.05, it means that that assumptions we made or the result it's showing is coming to alternate hypothesis, and null hypothesis is rejected. It means that alternate hypothesis means that the performance mean of both model are different, right? Means maybe our model is performing good than earlier or performing bad. Anything it can we can infer about that.
No,
Means
actually,
there is a significant difference between both.
no.
That both model are not.
Yes, sir. Actually, we are not having any base model. We just fine
No,
tune
no,
the
not
models which is already
yes,
available.
yes. Okay. Two things you want to compare. Wait, I am showing you the examples. Okay, suppose these are the things. Actually, I am explaining the same thing I am going to explain. Okay, hypothesis testing. So for any two groups, any two things, means suppose in mathematics we are saying that okay, 5 and 6 are equal. How we can prove? Means two samples, two numbers, 5 and 6. I am saying that both are equal. How we can prove? So using hypothesis testing, we can do this type of things.
How you are saying 5 and 6 both are same?
Equal,
How, sir? How it's possible?
equal.
Five and
Suppose mean of some groups are 5 and mean of some groups are 6, and I am saying that both are same. It means that there is no significant difference between both.
no
Okay,
significant difference means what meaning you are saying? I am not getting in that.
significant difference means suppose this is the curve, okay, and
Okay.
if our this is the null hypothesis from this to this one, this group, and the shaded part is alternate hypothesis, that is rejection area, and that is acceptance area. Okay, if anything comes under this one, okay, it
Okay.
means that our alternate hypothesis is accepted. It means that both are same, both the things we are considering are same.
So
If
is there any limit is there for null hypothesis and alternative
yes,
hypothesis?
yes, yes, yes. Based on the confidence interval, you can do. And suppose we are considering 99%, so it means that this will be here. The range will be smaller. Suppose we are considering 99%, means 99% of these curves comes under a null hypothesis, and only 1% we are saying that if the value comes under this region, then we are rejected. Then we will reject that things.
Okay.
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 Means mu plus minus 3 sigma, that theoretical things we have studied now. So if
Yes.
our assumptions comes under this one, so that means we are going to accept that assumptions. If that assumption is outside that, the alternate hypothesis is accepted, and we are going to the, so based on our requirement we do the testing. Means so this is the means beauty of hypothesis testing. So any type of testing based on our requirement, based on the problem, we can formulate. And suppose we are doing means in election or adding advertisement, we can see that means the population are different. Population mean is different. So for suppose election is going on in India and we take the sampling, what we do? We are not going to select all the population of India to study the things. Okay, what they do, they select some samples from there. Okay, that's why we say mu is the population mean, and that samples we take. Means suppose out of 1 crore or out of 5,000, we have selected only 100 samples to do the study. Okay, but that sample is sufficient to do the study or not? Suppose population is different, mu, and their mean is mu, and we have taken some samples from that mean, that population. That sample is sufficient. How we can say that to study the election things for particular region? Suppose in Bihar, okay, and बिहार पॉपुलेशन इस सम अमाउंट मीन्स मान लेते हैं कि 1 करोड़ 10 करोड़ है, तो इसमें से हमको कितना सैंपल लेना चाहिए स्टडी करने के लिए इलेक्शन के लिए, हाउ मच सैंपल्स वी शुड टेक, हाउ वी कैन डिसाइड. Okay, so we will do testing like this one, x bar minus mu by sigma. One t test is there, na? Wait. Okay, so what we'll do, we have some population mean and we have some sample mean, and we take the standard deviation for that sample. Okay, and based on that things we will calculate the z value, that is called z test. Okay, or t test we can say. Okay, and corresponding to that value we compute the
Sir, here how
value.
we can, here how we can choose this test which will be suitable for our study.
Yes, there are the
Uh,
things. Suppose we have some parametric and some non-parametric test, and suppose we have two groups, then we can go for t-test. And if sample size is more than 30, then we can apply t-test. Otherwise, we will apply z-test or t-student test. Okay. So there
so,
are some conditions.
so if I come to image analysis, all those things,
Hmm.
can I, because we are taking images, right? It will, if I feed it to deep learning, it is doing automatically and producing accuracy, all those things, right?
Yes,
So
yes. So
how,
it will
how,
not
how
depend on the number of images. It will depend on the performance parameter. Actually, we are going to validate the model, whether it is means we are going to compare two models based on their parameters, based on their performance parameters. So, how many values are there in performance parameters? That only we will consider in this testing to compare the things, compare the two models. Our aim is to compare two models, means how these models are good, means equal, means whether the performance of both are equal or not equal, right? So only performance parameters things we will consider here.
So for doing this test, can I follow the data science courses will be useful
Yes, yes.
or
Hmm.
any other platform can I follow? Because we can
One
do it.
example, one example I also want to say, means we want to do feature selection based on some testing. Okay, and suppose we have multi-class problem, more than two problems. Suppose only we have two class problem. Okay, and suppose we have 100 samples, out of which 50 samples are positive and 50 samples are negative, right?
Mhm.
And I want to say that whether this feature or attribute is able to classify the things, whether the sample is cat or dog. Getting my question?
Can you repeat it, sir? Can you repeat it if you can?
In our data set we have two class problem. We
Okay.
want to identify, means do the classification whether the sample is cat or dog based on some
Yes.
features. Okay,
Yes.
and now our aim is to rank that features, or means say that features whether this feature, particular feature f, is able to do this classification task or not, or if, what is the impact of these features on that particular result. Okay, so what we will do, we select, so our problem is two class problem now. So it means that we have two groups. We have selected 100 samples in our data set, out of which 50 are cat and 50 are dog. Okay, so see how we can relate with statistics now. We have one features, in that we have two groups, only two groups, and the sample size is more than 30. Let me consider this one. We can go for t-test. Okay, in that mean of one group is x1 bar, mean of second group is x2 bar, means mean of cat and mean of dog, right? We compute the standard deviation. So simply you can put t statistic, you can measure like this one. So we have t statistic. Wait. So how we can do? So in SciPy also the statistic formula is there, but formula is this one. You can see. See, is it visible to all of you?
Yes, sir. Yes, sir.
Yes. So x1 bar is mean of sample mean of cat. Suppose x1 is cat. X2 bar is sample mean of dog divided by standard deviation S1 by N1 S2 of N2. So this will give you the t value. Now you have t table. See, this one is good. So one sample test, if you have only one, means sample mean, and this is the population mean. And two sample test you can do here. So this formula we will apply. X1 bar is observed mean of first sample. X2 bar is observed mean of second sample, means second group. Consider here group. Okay. And S1 is the standard deviation of first group. S2 is the standard deviation of second group. N1 is the number of sample in first group. N2 is the number of sample in the second group. Okay. Now you have t value. Corresponding to this t value, you can compute p value by taking the t table. Okay. T table you can consider. Okay. Based on that p value, it will provide you the probability value. Okay. Now
Sir,
our sample.
can we do this thing using our Python is a good one,
Yes,
or we
yes,
can
yes.
go for?
Same thing I am going to explain actually.
Okay, okay. No, no. My question is, yeah, statisticians are available, and they are using some other SPSS tools like that. But
Yes,
we are,
same thing. Yes, yes, sir. Same thing we can do with Python also.
yeah, I'm asking whether it is possible in doing Python, like we can go for data science, all those things. Is it possible?
Yes, sir. Yes, sir. Yes, sir.
Okay.
So I am
So,
going to show you
okay,
how we can do.
okay, sir.
Okay.
Okay, okay,
So
okay,
these
sir.
are the basics. I think you all have the idea of basics. Like means to do any type of hypothesis. So that examples I will complete now. So we compute that things. Our null hypothesis is the mean sample of means cat group and mean sample of dog group are same, and alternate hypothesis is both are different, the means are different. Okay. So you can means just think, so if the sample of one group and sample of second group are same, then how that things can categorize something or able to detect something, both are saying both same thing. So how we can say, by using that thing, how we can say okay this one is cat or dog? We cannot say, right? So it means that that feature is not useful for us, so we can discard that feature. So can you relate that things with statistics now? So if our null hypothesis is accepted, it means that that feature is not useful for us. We should reject that feature. Only we will consider that feature that will uh, accept the alternate hypothesis, where means are not same. That is this one. X1 bar and X2 bar is not same. Here mu is written. So X1 bar and X2 bar means mean sample of cat and mean sample of dog are not same. That things are able to recognize okay this is cat and this is dog. That will differentiate the decision, right? So we will select only the features that will accepted in alternate hypothesis, right? So in this way we do the feature selection. So suppose we have two groups, so then we can go for t-test. Suppose we have multi-group, more than two group, then we can go for ANOVA test, analysis of variances. This is for multiple groups or multiple classes. So in
So,
this way we can do.
sir,
Yes,
here I have one doubt. You told about two tests and more than two tests. Okay.
more two groups and more than two groups.
Sorry, two groups and more than two groups. Okay. For
Yes,
example, here, if I'm going to deal with some cancer test,
yes,
identification of cancer disease or diagnosis of cancer, if
yeah,
I,
whether this is cancer or not, right?
yeah, if I am going to whether finding cancer or not a cancer. So for that, I
Yes.
have to go for t-test.
Yes, yes.
If I go to find out whether the cancer is in benign state or malignant state or in the final stage. So if I have a
Yes,
three category, if I have to go for ANOVA test.
yes, yes,
Okay.
yes.
Okay, sir. Thank you. I got some idea.
Okay. So based on problem, we will consider the testing methods. Okay. So in which type of test we have to do. So for any type of testing, these are the methods you have to mean the steps we have to follow. First of all, make the hypothesis. What are the hypotheses we are considering? That things we have to state. Okay. Based on that, we will do the computation. Identify the statistics and its probability distribution. Okay, so here in normal curve we have selected normal distribution. So what we have to do? First of all, in during pre-processing, all the data sets, all the data features will be mapped to normal distribution. Means data should be normalized in normal curve. Okay, then we can apply statistics like testing. Okay, means which type of distribution we are going to consider. Okay, now specify the significance level.
Sir, in
Means
this
90.
case, sir, in this case, you are dealing with the data that is Excel file, right?
Yes,
When
yes, sir.
we when
Yes,
we
sir.
go when we go for images, my output which I got that after the accuracy
No,
F1 score, that data I have to take and do it normalization
that is
and
the
then
last part, sir. Sir, that is the last part. If you are considering images and you are directly applying deep learning, actually.
yes,
Suppose we are applying machine learning things. So from images, what we have to do now? We have to first of all we have to compute the features, right?
okay,
Different you have to apply different filters on that, and then
yes,
that filter will be corresponding to each features. So different suppose you have applied 100 filters on the images, so 100 type of features you will be selected, right?
yes,
Now you have this matrix. Okay, means suppose
okay,
you have 10 images, means 100 images in your sample, 50
hmm,
of cats and 50 of dogs, out of which we have applied 50 filters. Okay,
okay,
and then you have 50 values for that.
okay,
So you have 100 cross 50 matrix.
hmm, okay,
Now now on this matrix you will build your model. Suppose linear regression, simplest one is linear regression. Okay,
hmm,
so now
yes,
you have 50 parameters.
yes,
Input parameters is 50,
yes,
output is either cat or dog. Based on this you will build your model and you will got the accuracy performance of these things, right? So
hmm,
out of 50 features, suppose we have to select whether these features are sufficient to recognize whether this is cat or not. Then you have to apply do the feature selection or feature reduction kind of thing, na? So we have to apply these things. Now last phase is to model means check whether model is good or not from the earlier one. And suppose some model is giving 99% accuracy and some model is giving 99.5% of accuracy.
hmm,
Okay, the difference is zero point 0.5,
yes,
but this point difference zero point 0.5 is significant. Can
hmm,
we say that this is significant or not? If this is significant, it means that your model is performing good. If
o-
this is not significant, then we say that okay, both model are working similar. There is no difference between both. Okay,
okay,
there is a difference between 99 and 99.5, but whether this difference is significant or not,
hmm,
statistically you can say. So based on this thing, based on this assumption, and based on this confidence interval, significance level, we can say that our model is performing good.
okay,
Okay.
okay, sir. Yeah, got it. Clear.
Okay. 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 So these are the steps. There are 7 steps. So first you state the hypothesis, then identify the statistics and its probability distribution curve. Based on that, you will calculate the probability. Okay, and then specify the significance level to compare the things, and then state the decision rules based on these things. Collect the data and perform the calculations, make the statistical decision, and make the economic or investment decision. Okay, so there are two types of test, that is one tail test and two tail test. Okay, so suppose we are doing this one, mu is always less than mu naught, and means only one kind of, means suppose mu equal to, means x1 bar equal not equal to x2 bar, so it may be either low or more or less. In both way we can go, but in this condition, if mu is less than mu naught or mu is greater than mu naught, so only one way we can go, so that is called one tail test. If you are going in both direction, that is suppose mu naught not equal to mu1 and mu1 equal to mu1, so in this way you can either go in greater or less, so that is two tail test. Okay, and here 5% is, that is confidence interval. So after doing this test, so this you can see this is the normal curve, and in high confidence this vertical line is the criteria. Okay, so after that, that p value is coming out of this, means 99 means 0.05. It means that if p value is less than 0.05, then your comes under rejection area, means alternate hypothesis is accepted. If the probability value comes under this one, this region, then you can say that your null hypothesis is accepted. So this is the case of one tail test, and this is the case of two tail test. In both way you have to check. Okay, so your point means your 5% 0.05 will be converted to 0.025, 0.025 this side and 0.025 this side. Okay, so in this way you can see, you can analyze the things. So these are the standard procedure. So here we have selected some data based on the votes only, that is election data. We have again using pandas library, we have selected this is the column for that. Stack overflow column is this one. We can go directly, I'm going to that test. Okay, here you can also see, means there are two types of test, like parametric and non-parametric. Okay, so in parametric test, assumption is assume a specific population distribution, that is normal curve or binomial curve or chi-square curve, means any type of uniform curve, which type of means distribution it's following. And in non-parametric test, no assumption about population distribution. Okay, so based on the problem, you can decide which, means which type of test we have to consider, either parametric or non-parametric. Data type requires interval or ratio data, nominal, ordinal, interval or ratio. Sample size more powerful with large sample sizes, can be effective with a small sample size also. Test statistic based on population parameter like mean, median. Oh, wait, sir. Hello. Yes. हम्म होगा ना, क्यों नहीं होगा? मैं थोड़ा लेट आऊंगा, जो टास्क दिया गया आप लोग कीजिए, ठीक है? मैं 2 बजे के करीब आऊंगा। ओके ओके, हाँ संतोष सर जाएंगे आप लोग को हेल्प करते। Okay, non-parametric test can be done based on ranking, differences, and frequencies. Okay, so actual data points are not there. In non-parametric, we will select some ranks based on the given data set. In parametric, we will calculate some mean, median, standard deviation. This type of parameters we will compute from the data set, and we will perform the statistics based on that. Like in t-test, x1 bar, and then s means standard deviation we have computed. Okay, so examples you can see: t-test ANOVA regression, and in this one, and Whitney U test, Wilcoxon test, chi-square test, Kruskal-Wallis test. Okay, there are many tests. So based on the requirement, we do. So these are the assumptions in parametric. It makes assumptions that the data is sampled from a specific distribution, like normal distribution, suppose. Okay, so these things we have to consider. Now, first test stage, Z test. We directly go here. So suppose we have data, click A is 200 and view, click and views we are considering. Okay. Now we want to perform A/B test or Z test on that. So we have just converted this test into this data frame, that is array, and the trial we have considered this one. Now we have applied a Z test. So see, this comes under what are the parameters? Test for proportions based on the normal Z test. So this is the functions defined in the Python. Okay, so it will give you the Z statistic value. Like in T test, it will provide you T value and P value. In Z test, it will provide you the Z value and P value, corresponding P value. Okay, so we have compared this one. This is the confidence interval. So 95% confidence interval we have selected. So if P value is less than this one, it means that there is a significant difference between the variations, means both are different. Okay, else no difference. That thing, the same thing we have discussed, no? See, so here P value is, Z value is 0 and P value is 1. So here P value is greater than 0.05. So our alternate hypothesis is rejected and null hypothesis is accepted, right? So here what is our assumptions? Both the things are same, right? Mean of both things are same. And here, so here you can see there is no significant statistically significant difference between both variations. So in this way you can perform the test. So the functions are already defined, like for T test. See, T test IND. Calculate the t-test for the means of two independent samples of scores. This is a test for the null hypothesis that two independent samples have identical average. Right? This is the null hypothesis, and alternate hypothesis is not identical. This test assumes that the populations have identical variances by default. Okay. And here we take the parameters in the form of array. So both groups we have to pass, like A group and B group, we have to pass, that is of type array type, and the array must have the same shape except in the dimensions corresponding to axis. If these are the parameters inside that we have to see. So if true, perform a standard independent two sample test that assumes equal population variance 1. If false, perform Walsh t-test. Okay, which doesn't assume equal population variance 2. So these are the all the descriptions is given in that. So everything you can. So whether two-sided or one-sided, you are going to consider. Then samples you can give, and it comes under SciPy package of Python.
So we have to follow SciPy, sir, for this
Yes,
statistics.
yes, sir.
Only SciPy can do this statistics, sir, or is there any other?
Yeah. in SciPy, these functions are available. So if
What about
another package is
scikit-learn, sir? Scikit-learn.
scikit-learn is used for machine learning things.
So in that also they are following some statistical tools. Whether we can apply that or
So
only
that will import the same thing, na?
uh,
That SciPy kind of thing they have imported. On the top of that, I think they have included in scikit. Okay.
okay.
So this package you have to import this one, SciPy. Okay, so bottom is CTR is this one, P value is this much. So this is also greater than 0.05. So in 95% of confidence interval, we can say that both are same. Both are same. There is no significant difference. Right? So I think your doubt is clear now.
Sir, how you are saying here both are same, but the values is different, right? 50.40.
Value is different, but our assumption for see our assumption we are our null hypothesis is the mean of both groups are same. Based on that, we are saying that there is no difference, there is no significant difference between group A and group B. If this value, if P value was 0.0 less than 0.05, means suppose P value is 0.4, 0.04, then we can say that okay, these are totally different things. That there is significant difference that will impact the things. Okay,
So it should be less than 0.5.
0.05.
Oh,
How much confidence interval you are considering based on the problem? If your problem is very much critical, like in health sector,
but
means
here,
cancerous.
you are getting 0.347, right?
Yes, that is greater than 0.05, na?
So if it is greater than 0.05, we called it
Means
as
that our null hypothesis is accepted.
okay. Well, if it is greater than 0.05, we called it as null hypothesis.
Yes. So in null hypothesis, what is our assumptions? Our assumption was both group have similar mean or same. यही बनाए थे ना हम लोग. उसके बेसिस पे हम लोग बोल रहे हैं कि दोनों दोनों में कोई सिग्निफिकेंट डिफरेंस नहीं है.
No, sir. Can you speak in English, please? I don't know Hindi.
Okay. So based on our hypothesis, we are saying that there is no significant difference between the mean of these two groups or these two things. Group B.
Okay, sir.
See here, randomly we have selected a data set and we have mapped that random value in normal distribution curve. So we are taking the random value in normal distribution curve. Okay. Then we can define the null hypothesis value. Null hypothesis means null mean is 9 and standard deviation is 2. Suppose calculate the z score value, that is sample mean, that is will be considered with this one. Here we are considering means calculating x bar minus mu by sigma. Mu is given, that is population mean. Standard deviation is given, that is standard deviation of population. And here now we will consider the sample mean. Sample mean is sample data, sum of all the points divided by n. Total number of sample is 100 here. So sample mean minus null mean divided by sample standard deviation root under sqrt of this one. So this will give you the z score. Based on this z, actually that was the formula implemented in library. But here we can do the manually. We know the formula for that and we can write the expression for that also. So p value will be 2 into 1 minus states.norm.cdf of absolute z score. This will give you the final p value for that. The cumulative distributive function, distributive function, cumulative distribution function, that will provide you the p value. Okay, based on this value and 95% confidence interval, alpha will be 1 minus confidence interval, that is 0.05, and z critical will be ppf 1 minus alpha by 2 for total test. That's why we consider, if we are considering total test, so 0.05 divided by 2, we have 0.025. So you can see how we can compute the critical value. Now based on this critical, we can compare the value. The margin of error will be z critical into standard deviation divided by this one, and confidence interval will be this one. Okay, now compare the p value with alpha. Alpha we know, p value computed by the z value. So if p value is less than alpha, it means that reject the null hypothesis, else accept the null hypothesis. So based on that randomly selected value from the normal curve, you can see z score is 0.5. Corresponding p value is 5.7 into 10 raised to minus 7. That is very very less than 0.025. होगा ना? This value is 0.000057. 57 means 6 zeros will be there, right? That is less than 0.025. It means that our null hypothesis is rejected and alternate hypothesis is accepted. It means that the sample mean and the population mean, that is 9 are having significant difference. Both having significant difference. Both are not equal. Okay, so if we are performing some election kind of thing, so we have to add some more samples inside that until we reach this. Both means should be, there is no significant difference between both. So based on the problem, we can make our assumptions. So for elections, we have to select the samples which will be the representative for the complete population. It means that the sample mean and population mean should be similar. There should be no significant difference. Getting my point?
Yes, sir.
So based on this, you can make the assumption. So here you have selected the value. So in a similar way, we have selected
Whatever,
from the,
sir,
yes,
whatever the things available, like in whatever app we are using in our mobile, the same thing we are
yes,
doing program here, right? We are doing program and we
yes,
are.
yes.
So what is the use of doing this program? Because already it's existing, right? Like as a app, if you are giving some values, it is producing output.
But we should know about the internal things so that we can develop more advanced tools,
Okay.
right? Because world is not going to end here, na? Day by
Yes.
day, it's exploring deeper and deeper.
Okay.
Earlier, there was no chat GPT or transformer based model, but now
Yes.
we have, right?
Yes, sir.
So when we learn some existing things, then we can build some new things based on the existing one, right?
So what are all the libraries should I learn for the statistical things alone?
Statistical SciPy is sufficient. So you
That's
should
enough.
NumPy, Panda, and SciPy. Three packages are very important for basic level of Python.
Okay.
And linear algebra in stats, I think linear ANG is there. Linear algebra is there. So all the basic mathematics you should know. before going to the machine learning or deep learning. Okay.
Okay. Is there any free source like
Yes, yes.
YouTube sources?
Everything is free. Python is free. All the packages
No,
are
no, no.
free.
I'm asking in YouTube sources which we can follow to get more knowledge on.
Yes, sir. Yes, sir. I will share the link.
Yeah.
There are many. There are many actually.
Because actually I am right now from medical college where I don't have knowledge in programming,
Yes.
so I'm just
Okay.
learning.
Okay.
Okay.
So there are many resources available. I will share you. Okay, sir.
Okay. Also, you share your email ID.
दिलचस्पी काम वाला काम
Yes,
करना होता
my
है ना,
email ID is
तो मुझे नींद नहीं
right
आएगी.
mukesh.kumar mukesh
Can you type
dot
in
kumar.
chat box, sir?
Yes. Wait, please. Okay. So now we have this data set.
Sir, am I audible?
Yes, yes, sir.
Sir, can we do design of experiment, those sort of things through this Python? And again, those are statistical tool. And I think it can be done by Python because again, it's a statistical math. But can we plot the graph related to that as well through all these things?
Yes, sir. Yes, sir. Same thing we can plot. Means
Uh-huh.
what we are doing.
Uh-huh.
The same the SNS plot or matplotlib was there. So that
Signal
is
to noise ratio, all that, those
yes,
things we have
yes,
done that.
sir. Everything you can plot. Only we are
So,
means we have data
uh, uh,
in the list or
uh,
array or data
uh,
frame. So if
अच्छा,
our data is in this form, then we can do
हाँ, हाँ,
anything. We can
अच्छा,
plot, we can do some metrics,
हाँ,
means
हाँ.
manipulations, mathematical expressions kind of thing. So
And
that
for
thing we
that,
can.
as well, we have to refer any library or any directly programming we have to do.
You can directly do means if your
हाँ,
mathematics is well,
हाँ, हाँ,
then we can same thing we can implement by writing the codes. Otherwise,
हाँ,
you can directly import that library and everything is already defined there. You can
हाँ,
directly
हाँ.
use the functions.
अच्छा, अच्छा.
Okay.
What could be the library for that design of experiment Taguchi?
Same
And
SciPy is there.
NO.
Sir. SciPy.
अच्छा,
No, NumPy and SciPy is
num,
sufficient for
अच्छा,
that.
NumPy and PyPy. Okay, okay. And
Yes.
sir, but
Same
there's a
thing.
mini,
NumPy,
there's a mini
Pandas,
tab.
and SciPy.
Okay. NumPy and SciPy. And sir, another
Yes.
question, like Minitab software is there. So, what's your takeout? Key, which is better, like Python, doing with Python or just referring Minitab to get the solution?
Both will give you good means same result. I
Uh-huh.
think Python we are using is because it is open source.
Acha, acha.
Minitab I have not explored
Acha,
actually,
acha. Okay,
but
okay.
actually, so Minitab is
It's a
it
very
paid or what?
yeah, but, it's a paid version, but for trial version also we can use it, and we get it's a very
Okay,
handy software where you can go through a lot of statistical methods like ANOVA, Taguchi, neural network, many things you can do by that.
okay, okay, sir. Okay,
Okay,
same
okay.
thing we can
Thank you.
do in
Here also,
free of cost using Python.
and graph also we can build, isn't it?
Yes, yes, yes.
Okay, okay. Thank you, sir.
So based on our means how much comfortable we are with this one,
Okay,
we can
okay,
perform.
okay. So you have done that programming for design of experiment.
Yes, in a similar way we can do. Design of
Acha,
experiment is the same, I think.
acha,
That thing I am explaining now.
acha.
So
Okay,
design of
okay.
experiment is also same.
Okay.
In design
Thank
of
you so much.
experiment, same thing we have to do now. Means we have to make the assumptions. We
Yeah,
have to
signal
means
to
what are
noise
the
ratio you
our
have to calculate.
yes,
Maximize,
yes.
minimize, all those things you have to do.
Okay.
Okay, sir. Thank you so much.
So we can do. No issue, sir. See, so our curve is following normal curve here. Okay. If it is not following, then we have to transform our data in this to this curve. We have to map. Okay. So which type of distribution we are going to consider? So now calculate the proportion of late shipments, print the results, hypothesis that the proportion is 6%. Okay, calculate the standard error, Z score. Based on the Z score, we means our population mean. Because here this is the mean. So now we have to calculate the p value. So here Z value is 0.13, corresponding p value is 0.44. Okay. Now based on the confidence interval, we will make our decision. Okay. So what is the significance of alpha in decision making that we already discussed? So by comparing the p-value of the significance level alpha, you can make a decision about which hypothesis to support. Okay. So if p-value is the measure of evidence against the null hypothesis, the null hypothesis assumes no significant difference or relationship between variables. Alternate hypothesis suggests a significant difference or relationship. Okay, and significance level is chosen as the threshold for decision making that we already seen and explained also. Calculate the p-value, which represents the probability of obtaining the observed data, or more extreme if the null hypothesis is true. If the p-value is less than alpha, typically 0.05 or 0.01. 0.05 means 95% confidence interval. 0.0 means 90% confidence interval. We will reject the null hypothesis, and rejecting the null hypothesis indicates evidence in support of the alternate hypothesis. And if p value is greater than alpha, you fail to reject the null hypothesis. It means that we are accepting the alternate hypothesis. And this decision should be interpreted in the context of the study of the experiment or practical implications, right? So based on our assumptions, based on our context, based on our problem, we will make the or interpret the this decision. Okay. So in this way, you can interpret the confidence interval using quartile method. So in statistics or hypothesis testing, there are two types of error: type 1 error and type 2 errors. So type 1 error, that is false positive. Type 1 error occurs when a null hypothesis that is actually true. Okay, that is false positive. We are predicting false, but actually it was true. In other words, you conclude that there is a significant effect or difference when in reality there is none. Means in reality there is no difference, but after testing, it's showing that there is a difference, right? So the probability of committing a type 1 error is denoted by the significant level alpha. Type 2 error, that is false negative, actually it was negative, that you fail to reject a null hypothesis, that is actually false, but not able to reject. Okay. Type 1 is actually it is true, but we have our null is rejected. Type 2 error is actually it is false, but we are not able to reject our null hypothesis, fail to reject. Then it's a false negative. So in other words, you conclude that there is no significant effect or difference when in reality there is one. The probability of committing a type 2 error is denoted by beta. Okay, so same thing we can use using SciPy to alpha. Here you have used sample t test, one sample test. Okay, and we compute all these things, type 1 error and type 2 error. So type 1 error is this one and type 2 error is this. So now we are going to use identify population parameter is hypothesized about, specify the null and alternate hypothesis, determine the t-test statistic and corresponding distribution, conduct hypothesis test, measure evidence against the null hypothesis, make a decision comparing evidence to significant level, and interpret the result in the context of original problem. So in scipy.stats, we have this function t-test ind. So it will perform total test. We have to provide sample 1 and sample 2. Sample 1 we have selected randomly from the normal distribution, and sample 2 we have selected randomly from the normal distribution, and both we have passed here. Okay, now our null hypothesis is the mean of both samples. Sample 1 and sample 2 are same and alternate is not same. So your t value you can see minus 0.7 minus 7.041, and corresponding p value is 0.0000011 10 times 0 3. That is very smaller than 0.025. If we say 95% confidence interval, it means that alternate hypothesis is accepted and null hypothesis is rejected. Means the mean, there is significant difference between both samples mean, right? In a similar way we can apply ANOVA test. So ANOVA test we have using these functions stats.f one-way ANOVA. Perform one-way ANOVA. The one-way ANOVA test the null hypothesis that two or more groups have the same population mean, and the test is applied to samples from two or more groups, possibly with different. T value is minus 0.2 and F value is 4. If you apply T test and ANOVA P value. And what will be the P value? P ANOVA. Okay, based on the P value, they have not printed. Let me print first. T value and P value. Let me print, then we will see the difference. T test and okay. So here T value is minus 0.2 and their corresponding P value is minus 0.08, that is greater than 0.05. So null hypothesis is accepted, and corresponding to this one. Fail to reject the null hypothesis. Yes, null hypothesis is accepted for the t-test. This means that the two samples may be equal. Okay. From here also we have concluded that this p-value is greater than 0.05, it means that there is no significant difference, means null hypothesis is accepted. Okay, and in next conclusion, fail to reject the null hypothesis for ANOVA test. This means that the two samples may be equal. Same p-value is also so greater than 0.05. It means that alternate hypothesis is rejected and null hypothesis is accepted. Okay, but sample mean you can see here 3 and 5. So if we see mean of both groups, we can easily say that there is difference between 3 and 5, but statistically there is no significant difference between these two experiments. Okay, is it clear? I think it is clear to all of you. So in the same way, for another group, another things we have done. So fail to reject the null hypothesis. Here you can see. So all things we have described. So any doubt? No doubt. And we can also draw the PDF functions. Yeah, based on the curve, given curve, we can compute the PDF or CDF value. So any doubt here?
Sir, one more doubt I have. Like, I'm from mechanical background. Which libraries will be useful for my mechanical background?
Which library is useful for?
Mechanical field, mechanical engineering.
Same library we can use, sir. Based on our requirements, we can really make the decision based on our requirement. No? So only decision and in which context we are explaining the things. Library will be same. Only we have to means like in medical field. Suppose we are going to measure the blood pressure measure before treatment. Okay, and blood pressure measure after treatment. So we have data in the list. Same thing we can means apply into the array. Okay, and just t-test we have applied here, before treatment data and after treatment data we have given. Based on this we will calculate t-test and p-value. So we suppose we want to check whether that medicine is useful on this patient or not. Means before treatment, if these are the readings, and after medications or by taking some medicines, these are the readings. So only we want to check the role of or impact of that medicine, whether that medicine is impactful or not, right? So from this result, what we achieved? So in t-test, t value is 21.3 this much, and p value is 5.188 into 10 raised to minus 9, means very less than 0, means 0.05 or 0.025. Or if you consider 99% confidence interval, means very less than, it's also less than 0.0 0.001. Okay, very less, no? Almost zero. It means that null hypothesis is rejected and alternate hypothesis is accepted here. It means that there is a significant difference between the mean of both things before treatment and after treatment. It means that there is a significant impact of that medicine on these patients. So जो भी medicine हम लोग लिए हैं, that medicine is useful for treatment of BP patients, right? So in this way we can make the assumptions. So in any field, like suppose in mechanical uh, engineering, suppose we want to check the quality or maintenance we want to do for any machine. So we should have readings and before and after, and then we can make the assumptions, means which type of things we have. Okay. So same.
And sir, these libraries just have values and ratings, or is it also have the
Class.
coding for mathematical analysis?
Please repeat, sir.
Like these
Hello.
libraries, it just has x values and y values, or it has mathematical formulations as well.
Mathematical formulation as well. These are already defined. That functions we are using, like this one. Suppose these things. So here we can see how they have means implemented and what are the parameters we should provide here. Mathematics is same for t test, x bar minus x2 bar divided by s1 square divided by n1. That was na. That is same for all. But only we have to write the code for these things. Okay, so we can replace by writing our own code. These functions we can replace easily. Okay, but in this package, that scipy package, these things are available. So you don't want to write the code, you directly go and import that package and or library, and from that one you can use this function, so it will work. Okay, if you don't
Okay.
want to use scipy, write your own code. Okay, so now we are stopping here. If you have any doubt, you can mail me. Okay. So is there any confusion or doubt? So can you stop now, sir? Please let me know.
Hello.
Yes, ma'am.
So if there is no queries from the participants, then we can wrap up this session. So on behalf of Professor Gaurav Trivedi, sir, the Principal Investigator of IIT Academy, IIT Guwahati, and on behalf of Dr. Aryavrita Sahu, sir, who is also the Principal Coordinator for this course, I thank you, sir, for accepting our request for taking class in this course and joining with us today and taking such a beautiful lecture and enlightening all the participants.
Thank you, ma'am. Thank you, everyone. I
Thank
am
you, sir.
stopping now. Okay. Okay. Thank you.
So, dear participants, thank you all for cooperating and completing this day is 8 of this program. Only 2 days are remaining, tomorrow and day after tomorrow. Tomorrow there will be MCQ number 2, which I will be noting down. From 2 to 3 it will be conducted. So we request all the participants to make yourself free during that period. From 2 to 3, at least for 10-15 minutes, make yourself free, because it will be only 20 questions, which will take hardly 15 minutes to answer. We request all the participants to please take out 15 minutes time slot from 2 to 3 and join the MCQ of the course, second MCQ of the course. That's it from our end. Thank you all for joining. Thank you, everyone. Also, request the participants to note that the attendance of day 7 is updated. Okay, attendance of 5 and 6 are under scrutiny. So it will be updated and announced in the WhatsApp group by the end of the day. Thank you all.
Ma'am, can you please share this today session recording and slide in that, right?
Yeah, it is every day shared only. Okay, by default, it is shared by the end of the day. See, now the meeting is going on. To create the recording, it will take some time for WebEx also. So once it is created, we will download it and then upload it in the Google Drive link. Okay, in the respective day folder, you can find it out.
Ma'am, I have a query that the link what you have given in which we have all the what we say notes and video recordings. So will that be forever in future also we can access
No,
it?
no. It won't be forever. So after the end of the course, during the valedictory, we will be announcing that you have to download it and save it in your system for
How
your
many times?
personal reference in the future. Also, there will be certificate distribution, okay, which link will also be provided through Google Drive only. So we request all the participants to download your details and your certificates and keep a copy with you for your future reference, because these links won't be for entire for a lifetime. These are not lifetime links. Yeah.
So at least for maybe 15 or 20 days it will be active.
Yeah, for 15-20 days it will be there, but not more than 1 month. Okay, so we request not to delay the thing or procrastinate the thing. Download it as soon as the course finishes. On the last day itself, we will be announcing new that yes, the drive is completed and everything is uploaded at the end of the course. And once we announce, you can download it for your future reference.
And one more thing, madam, I had called for a fee receipt once. So can we get that fee receipt? Because it is being reimbursed from my institute.
Okay, yeah. We will provide you a soft copy in the mail itself. We will provide.
Okay, ma'am. Thank you so much.
Yeah, Hari Kumar Naidu sir, we have already shared the attendance sheet in the email also. In fact, in the drive itself, in the drive link itself, when you click, you will find the attendance sheet in there only.
Thank you.
So those who are not able to join the WhatsApp group, they can follow the drive link. Okay, in the announcement sheet, all the announcements are provided. I guess there are no doubts from the participants. So in that case, we request the participants to please log out from the link. The meeting link will be deactivated in another 2 minutes. Tomorrow again the session will start from 10. So we request all the participants to be on.